I wanted to just welcome you all here. Thanks for taking the time today. The theme for today is large language models and generative AI. And unless you've actually been living under a rock, it's extremely unlikely that you won't have heard about this before. Generative AI across modalities, ChatGPT in particular, Bard, Bloom, and many others, some of which we'll learn quite a bit more about today, hopefully. So the new technology, it's really captured the limelight, and it's stimulated this really interesting public discourse and debate around the potential, the ethics, the safety of this rapidly developing technology, and it's really rapid. So ChatGPT is the fastest growing kind of web app, beating TikTok and by some distance, and Instagram obviously as well. With more than a million monthly users earlier this year. So it really is extraordinary. The public discourse has been pretty intense and arguably extreme in some cases. Disruption, the potential harm of this technology, the regulation or unregulation posture, issues of privacy and ethics and access. So the purpose of today's event is to cut through some of that noise and the hype and the hyperbole. And we're going to hear from experts from industry, from academia and from government. And we're going to hear their takes and their perspectives on this phenomenon and its impact, potential impact. We're going to share information on ADAPT, and Professor Dave Lewis will talk a little bit about ADAPT in a moment, and our role in the ecosystem in Ireland and further afield in Europe and internationally. And we'll hear from some of our ADAPT experts, professors in computer science and in engineering. And they're all very active researchers in this space. So you've come to the right place. So ADAPT, as a human-centric AI research center, we've been working with this technology for many years now. I know it's really blown up in the last 6 months or more, but we've been at this for a long time. So even in 2016, our colleague Professor Andy Way in DCU was working on neural machine translation technology in 2016, and NMTs are pretty much large language models. So we've got this strong background in this particular domain. So today we're going to provide you insights and navigation on how ADAPT can help you and your company or your organization get to grips with the new technology. I've realized I forgot to advance my slides. Okay, so the agenda for today, it really is action-packed, and I'm not going to go through it in huge detail, but just to call out, Professor Dave Lewis will be next just in a couple of moments, and he'll introduce ADAPT and the AI landscape. And then we're fortunate to have our colleague in DCU, Professor Anya Belts, and she'll take a first look at large pre-trained language models. Then we have our first industry insight, and that's with Paul Barnes, who's Group Engineering Manager with Microsoft Europe Development Centre here in Dublin. And he'll be talking about leveraging large language models at scale through Microsoft 365. And I think many enterprises, that will be really their first kind of hands-on access to the technology. Then we have an interesting panel discussion, which will look at generative AI and its impact, its disruptive impact on industry. And then we will have a short break of 15 minutes, use the bathroom, grab a coffee. And then the second half, we'll start with our second ADAPT deep dive, and that's going to be with our colleague in Maynooth, Professor John Kelleher, and he'll be talking about opportunities and challenges and future directions with generative AI. Then we're into, Then we're into our second panel. And the second panel will look at data ethics and AI regulation. So in this new world for generative AI. Then we have our second industry deeper dive, and that's going to be with Dr. Keane Hughes, who's a clinical research scientist with Google Health, also here in Dublin. And he'll be talking about LLMs in the medical domain, which is really, one of the critical application areas for the technology. Then after QA, I'll wrap up and we'll be into the poster session. So I'll be touching base on the agenda throughout the day, so you don't have to memorize all of that. And without further ado, I'm going to hand over to Dave Lewis. Yeah.
Thanks, Declan. So yes, my name's Dave Lewis. I'm a professor in the Trinity School of Computer Science and Statistics, where till recently I was the head of the AI discipline until November, when I took over as the interim director of ADAPT, following on from many years of service of Vinnie Wade, who many of you probably have met previously. So a little bit about who we are, Adapt Centre. Okay, so Adapt Centre is one of the 16 or so Science Foundation Ireland-funded research centres. We're a multi-institutional centre, so there's 8 universities across Ireland, so we're really a cross-island, at least, you know, within the Republic, we have universities across the state. And we act as a single virtual center. So though we have multiple institutions, we have a common center support mechanism, which is where we engage with our many industry and academic collaborative partners. And in terms of, you know, who we are, we're essentially a group of around over 80 what we call principal investigators or funded investigators. So these are academics across those 8 institutions who are working in our broad overall sort of area, which is AI-driven digital content technology. So as Declan's mentioned, you know, our real focus is on using AI specifically in areas where we're dealing with content. So that's the type of data that is either generated and or consumed by people. So the things that we're interacting with every day, the AI that sits behind our speakers, behind our screens, behind our virtual reality headsets, etc. And we've had a very strong expertise over many years in areas like machine translation, multimodal information retrieval, personalization, but also areas such as knowledge graphs, use of open standards to help us with the management and governance of this technology. So I say we're made up of around 80 odd funding investigators, a number of other collaborators who are other academics, both in Ireland, internationally, and also collaborators in many of our industry partners as well. And I think what's interesting when you look at our sort of core faculty, though obviously we're technologically focused, actually, you know, probably only roughly over half of that number would be computer science academics. The rest being very, very multidisciplinary. So other STEM researchers in some of the other natural sciences, lots of people in health and medical research, lots of people in humanities and social sciences. And we find this is absolutely necessary now to address the issues of AI. You know, I think we're all feeling this, you know, disconcerting acceleration in the effectiveness and rapidity with which the technology is being developed. And, you know, that impacts us at many levels. So as individuals, we're having to sort of figure out, you know, well, you know, why am I being fed this particular content? Why are people seeking, you know, people are seeking my attention constantly. What are they trying to, you know, do with that attention? You know, is it disinformation? Is it advertising? Is it just entertaining or informing or educating me? That's a pressure on us to figure out exactly what we're being faced with. Then at an organizational level, both, you know, commercial and non-commercial organizations, we're seeing really rapid changes and disruptions to our operational models and our business models. So the types of skills that we need are changing really quickly. The type of capabilities that we, you know, previously found it takes a long time to adapt to it, we're finding technology is catching up really quickly. So we're dealing with a lot of disruption. And that disruption also bleeds through to a societal level. So we're having to look at a more broadly, well, you know, what are the downsides of some of this technology? What are some of the new types of harms that we hadn't anticipated, or we haven't had enough time to digest and understand what those harms are? And how do we react? How can our institutions, our regulations and our laws adapt to the pace of change that we're dealing with? And then finally, you know, even the organizations themselves that are advancing this technology find that they then have the challenge of actually, you know, figuring out how to do this in a trustworthy way. How do they gain people's confidence that they are actually progressing in a direction that will avoid some of these harms? So we've all got lots of these, you know, problems to try and deal with together. And that's why we need multiple viewpoints, multiple actors. So we need industry, academia, government, civil society, all engaged in this. So in Adapt, we focus this around the idea of human-centric AI, and we look at this through three perspectives. There's the sort of the algorithmic perspective, where we bring that sort of ICT expertise into play, looking at how do we actually develop these algorithms in a way, especially a big focus for us is that do it in a way that is inclusive. So can we sort of make sure that all the different types of groups out there, regardless of the languages they speak or the forms of language that they use, will be fully supported. We're not, going to the baseline of doing everything in English, for example. We also look at this from an individual perspective where, we're looking at research around conversational agents. What are the forms of hyper personalization and interaction, and if you like, the AI almost getting into our heads and sort of anticipating what we might do next. And how can we both develop that technology in a way that's useful, but make sure that it's also under meaningful control of the people who are interacting with it. And then finally, the realization that we have to manage and govern this technology. It can't sort of shoot ahead without appropriate oversight. So at a sort of from an enterprise and a societal perspective, we need to understand what governance mechanisms we need in there and what are the mechanisms, the new mechanisms we need to actually govern this technology. So just to wrap up, quickly, as I say, we're looking at this from multiple disciplinary angles, from multiple partners and stakeholders. And to give you a little bit of idea of where we're sort of placed, on the landscape, certainly both from a sort of a research policy and a standards perspective, we're very active. So for example, some of the major academic conferences like ACL, which is the top natural language processing conference we hosted here in Dublin last year. We have Interspeech, which is the main speech technology conference, will be held here in Dublin in August. And that's, through leadership of our academic cohort. We also have policy engagement. So for example, the European Language Equality project that we collaborate with at a European level that gives evidence to the European Parliament on how natural language technology can support all of the European languages in an equal way. And also contributing to standards. So we've been engaged in the ISO international standards for AI and trustworthy AI since the inception of that work from about 2018. And interestingly, that's now strongly feeding into the implementation of the EU's AI Act. We might talk a bit more about that in the panel later. Also, we innovation is a big part of what we do. So that we have real research excellence. We do a lot of licensing with our industry partners and also a lot of spin-outs that come out of that. So an example there might be AI Map It, which is a recent spin-out from Trinity that arose from a project that we did doing video analysis of sort of street view type content to, count things like telegraph poles and audit those for companies that, dig up the road, etc. And also a real, if you like, the beating heart of a centre like ADAPT that's been running many years and hopes to run many more years into the future is the skills development that we do. So we've really grown hugely, especially with a lot of European support, skills development at the postdoctoral level in areas like standardization, digital transition, at the PhD level, looking at in areas of health and AI regulation, and even at the master's level, looking again at sustainable AI and law and data ethics aspects of AI. So that's a very, very, very quick sort of run through of some of the things that we're working on, some of the outputs that you're seeing from ADAPT. You'll get a chance to see some of that in a little bit more detail in some of the posters, and hopefully you'll hear a good bit of discussion about that as well through some of our panels and some of our presenters that you'll hear from in a minute. So with that, I'll pass on.
Thanks, Dave. So what Dave didn't say there actually is that our ADAPT vision, which is towards a balanced digital society by 2030 with control, inclusion and accountability. We kind of framed that in sort of 2018, 2019, and it sort of formed the bedrock of our phase 2 research program, which runs till the end of 2026. And so it's kind of now more than ever, that sort of same vision is still very highly relevant. Right. So next up in this session, we're taking a first look at large pre-trained language models. And to speak about this, we have an international leader in natural language processing. Professor Anja Belz is a professor of computer science at Dublin City University and a PI in the ADAPT Centre.
Let's just scroll.
Yeah.
No. Sorry, it really needs 3 hands, so I'm going to try and work out how to do this. Right, so I've worked in AI and natural language processing for about 20 odd years now, working with neural methods and language models from around the year 2000. So it's been quite a long time. And for most of my career, the media and the general public were barely aware of what us AI researchers were doing or what AI was in the general case. There may have been the occasional report in the media about a specific app that worked particularly well, but for many years that was about it. So that started changing from about 2019 onwards, as you may recall. So this here was the publicity stunt by OpenAI in 2019, when they triggered an absolute media storm by announcing that they were not releasing GPT-2 because it was too dangerous. How times have changed. So the next big media storm, would you do that? That might work a lot better, thanks. So the next big media storm came in May last year, when that Google engineer decided that the Lambda chatbot had become sentient. And then in November last year, if you just keep on clicking, ChatGPT, of course, happened, causing an even bigger furore. The headlines became really quite florid, especially in the tabloids, as you can see here. Next one. But we've also had an impressive number of AI sector leaders declaring themselves worried about the dangers of the current generation of AI technology and asking for the first time for sector regulation. So the media are in a stew about psycho chatbots and worrying about AI destroying humanity. And what's new this year is that the tech sector leaders are now apparently also worried about AI destroying humanity. So it seems clear that something important has happened, that we've reached a milestone moment, before and after moment, as one of the headlines just now called it. So what I'd like to do in this talk is to take a look at what this milestone moment is and how we've reached it. So in other words, how did we get here and where exactly is here? So language models, large language models like ChatGPT, they are at their core just that, they're language models. So while these are now larger than ever, language models as a technology are of course not new. They've been around for quite a long time. They were used for speech recognition successfully from the 1980s onwards. They powered the early machine translation apps, including Google Translate from the early 2000s. And the underlying ideas go back much further than that. For example, they helped crack the Enigma code in World War II. So language models are probability distributions over sequences of words. And once they're trained, language models can assign probabilities to unseen sequences of words, any sequences of words, on the basis of the data they were trained on. So this turns out to be extremely useful for a range of different language tasks, including, for example, word choice and word boundary detection, for example, for speech recognition, where it's extremely helpful to know that the probability of a word sequence like he recognized him is always going to be much greater than the probability of a word sequence like he recognized him, which to a speech recognition system sounds very similar, but as humans we know one is far more likely than the other. Another example is word ordering, for example, for machine translation, where similarly it helps to know that the probability of a word sequence of a word ordering like the weather is nice is far more likely than an ordering like nice the is weather, even in languages where word ordering is fairly free. So most language models, including the state-of-the-art transformer language models, which I'll come back to in a moment, decompose the joint probability of word sequences into the product of conditional probabilities via the chain rule. This, in practical terms, is very important. Because this decomposition is exact, it allows us to efficiently learn a language model over word sequences by simply learning the conditional probabilities of individual words, given the word sequence, the sequence of words preceding the individual word. This autoregressive formulation, as it's called, allows the generation of word sequences one word at a time by selecting the most likely word given the words that have been generated so far. So this is the crucial bit of methodology that allows the generative aspect of language models. So the ability to predict the continuation of word sequences turns out to be extremely powerful. For many language tasks, you can construe them in this way. So for example, for machine translation, a translation can be construed as the continuation of the source language text. In dialogue, the answer can be construed as the continuation of the previous turn, or the next turn can be construed as the continuation of the previous turn. And in question answering, the answer can be construed as the continuation of the question. So far, so good. But what's taken absolutely everybody by surprise is that when language models get very large, and when they're trained on very large amounts of data, they start to be able to do many more tasks above and beyond language tasks. So the powerhouse that's been driving this revolution, these developments, this rapid progress, is neural computing, and more precisely a particular type of neural architecture, the transformer. So this had its origins in work in a group at Montreal University in deep learning that was started being used for MT, machine translation, from 2013-14 onwards. And this led to the idea of attention, another crucial part of the modern neural toolbox. So this means that you learn which part of the input you need to pay more attention to in predicting the output. And this work culminated in 2017 in the Attention is All You Need paper by Vaswani et al. At Google, which is one of the most cited papers ever in computer science. And this paper introduced the transformer architecture, initially for machine translation, and then later repurposed for general language modeling. And on the right here, you can see the original transformer architecture, which was for machine translation. And then the more recent version of this for language modeling, which is used, for example, in GPT. Now, it's the ability of transformers to combine scalability with modeling power that's been driving the explosion in applications that we've been seeing. All of the current state-of-the-art language models are variants of transformers. This is the degree to which they've taken over the field. And the reason why we're seeing these massive breakthroughs now that we've been seeing over the past year is that computing power and the quantity of data has caught up with what these models can do, and that's only very recent. So this explains a lot of the recent progress that we've seen. So previously, what we would have expected to do with the language model is that we would take it, if we wanted to solve a particular task, develop a particular application, we would fine-tune it on some task-specific data. But state-of-the-art language models like the GPT family, from 3.5 and 4 onwards, can do many tasks without any fine-tuning whatsoever at all, simply straight out of the box. And the reason for this is that they're no longer just basic language models in the sense that I described earlier, probability distributions over sequences of words. So we still have the base model here in this diagram shown right at the bottom there, which are straightforward large language models trained to maximize the probability of large amounts of data that's been scraped from online and other sources. So that's still a straightforward language model. But this general base model is then via fine-tuning and reinforcement learning from human feedback, or RLHF, adapted to be good to specialize in interpreting instructions from human users. So that gives us the second layer here. Alternatively, you can do a combination of instruction and dialogue tuning, which is how you get a dialogue model such as ChatGPT. So that gives us the third layer. Additionally, we now have, and that's another very recent development, tool-augmented language models, which I'll come back to in more detail in a moment. So how do you use these different layers of the stack? If you wanted some form of a chatbot, then clearly you would use the dialogue-tuned layer, giving you ChatGPT, for example. If you wanted a solution to a given language task or another task is no longer just restricted to language, you would use the instruction layer. So giving you instruct GPT, for example. And what you would do is you simply ask it straight out of the box what the output is for a given input. So for example, you could ask it what the English translation is for a given French sentence, and it will happily give it to you. It would also work for a smaller language like Irish, perhaps not quite as well, but in general, this works surprisingly well for lots of different tasks, provided you know how to ask the right question. So knowing how to ask the right question is absolutely crucial. So this here at the top is a list of rules of thumb provided on the GPT website, how you should construct your prompts, your questions to the model so that it gives you a good answer. So it's a list of tips for formulating questions, for zero-shot and few-shot GPT prompting for specific tasks. It's a long list, so I'm just going to pick a few examples here. You need to use the right model. That's important. So even from the same generation, there will be differences in performance between the different versions of the same generation of GPT. You need to use the right prompt format. You need to be precise, and you need to not use negation. Negation's been an issue for language processing throughout its history. So that's some things apparently don't change. But what also matters is the structure and the narrative of prompts. So for example, a narrative structure that has come to be called chain of thought prompting works particularly well across a multitude of different tasks. Whereas other types of structure, like decomposing a task into separate steps as part of your prompt, work well for certain contexts, but not so well for others. You can also do absolutely minimal instruction prompting without examples or steps, and that's still, so this is simply as you would naturally tell another human how to do a task. And this does work well for certain tasks, but we're finding this quite unpredictable. So this is some of our recent work where we've been looking at few-shot and zero-shot prompting for the task of semantic consistency assessment. So this is the task where you look at two texts, or you look at a table of data and a text, and the task is to decide whether they convey the same information, whether they have the same semantic content. So when we tested this, we tried out a variety of different prompts, as you can see in the first column in the table over there on the right. The next two columns give you the accuracy and F1 evaluation scores over a test set that we used. And so you can see, so these are the prompt types I mentioned just now: chain of thought, task decomposition, and then at the top, 4 different variations of minimal instruction prompting. And as you can see, the accuracy and the F1 scores vary quite significantly depending on which form of prompting you carry out. And this is all work with my students, Michaela Lorandi, Mohammed Sabri, and Rujali Hujum. Mohammed has a poster at the back, which is on something related to this. So it does matter how you ask a question. You have to know how to ask the right question. The sensitivity is important. It means you need to do prompt engineering to get the best performance for a particular task out of a language model. But it also means that asking single questions of ChatGPT, for example, and drawing conclusions about what it does and doesn't know on the basis of a single question, its answer to that single question, more precisely, is not a very meaningful thing to do. Because as you can see from the performance results, you might get completely different answers, different quality of performance depending on how you ask that question. On the other hand, how to do this properly, how to properly establish the extent of the capabilities of a given large language models is currently unclear. We don't know how to do this in the general case. So I'm now going to take a slightly closer look at tool augmentation, which I think may be a more significant development even than the very large language models with their amazing out-of-the-box abilities. So one of the first tool-augmented large language models was WebGPT, which is a version of GPT that's trained on performing the higher level task of using a search engine to answer open-ended questions. Something that we can do easily as humans, and that it turns out a language model can learn relatively easily by imitating us. So the first step, as we saw in the emerging default large language model technology stack a few slides back, we have these two cycles of fine-tuning followed by reinforcement learning from human feedback. So for the fine-tuning phase of that, data is collected from human trainers, as they call them, who perform the exact same task that you then want the language model to perform later. So on the top right here, you can see the environment as it would look to a human trainer. So they're given an open-ended question, they perform web search. It will tend to be a question that they just don't know the answer to. So they go on the web, they find the answer, and then they collate, or they find lots of text snippets, and then they collate an answer which they in the system case return to the user, and in the trainer case they store as part of the training data. So as the human trainers go along performing their tasks, the environment state and the commands selected by the human trainer at each step are transcribed to text format and recorded. And to the right here at the bottom, you can see the text format version of the environment state shown at the top right here. So the reason why it has to be text is clearly that we're dealing with language models. So we have to convert the interface, which we can interpret, but a language model can't, into text only. So the commands that the human trainers can choose and that later then the language model will be trained on during fine-tuning are all the tasks, the commands that you would normally expect to carry out when performing open-ended web search. They include entering the search query, scrolling through the results, following links, extracting and copying some text from the websites you visit. And then eventually, when you decide you've got enough content, switching to answering mode and composing your answer. Next, please. So during the fine-tuning then, once you've collected all your data and you start the fine-tuning phase, the supervision for the training is provided by the commands that were selected by the humans and the parameters. Plus then the final answer generated in the last step. During the reward-based phase, human feedback is used on alternative commands and answers. And once the system is fully trained, it can then independently interact with a text-based web browsing environment. And at each step, the language model then self-prompts with the original question, the original open-ended question, and a summary of the current environment state, which is initially empty. The command that it selects then in response to the prompt is carried out. The text and the values returned from the command are added to environment state and are then used as a fresh prompt to the language model. So this ends up being an iterative cycle of self-prompting. Sorry, the graphics have gone slightly awry here, where the environment state is passed in text form to the language model as the prompt. The language model returns a command with parameters to pass to the API call, the API to the web search app. The API call returns certain results. So in this case, it'll be mostly URLs. And then we get that added to the environment state, which is also slightly updated in other ways. And that then becomes the next prompt. And we go around in this iteration until the model decides all of this completely independently. It's time, it's got enough material to start composing the answer, and then it returns the answer to the user. So once it's been trained, WebGPT, and this is already 2 years old, which I think is quite astonishing to think. Once it's trained, it completely independently decides when and how to submit search queries, to visit and scroll through web pages, return in search results, and copy text extracts, among other things that I mentioned. So earlier this year, we had a paper on Toolformer, which is also a tool-augmented language model, but it demonstrates tool augmentation for a range of different tools, not just web search, including also question answering, access to a calculator, and machine translation. So we're now at a point where, in principle, as long as it has an API, any tool can be linked up to a language model in similar fashion. So to support this new ability that we have, libraries, development platforms, startups, etc., are racing to provide support for creating tool-augmented large language models. One of the best known examples, one of the most used, is shown here on the right, Langchain, which started out as a Python library, which is now a general framework for developing applications powered by language models. And as the companies say on their website, their vision is that the most powerful and differentiated applications will not only call out to language models via an API, but they will also be data aware, that is enabled to collect data from elsewhere to use in producing their answers, their responses, and they will also be agentic, allowing a language model to interact with its environment. So what we saw just then is an example for WebGPT was an example of an agentic language model. So companies, including companies that we're working with, have started using Langchain to build applications that are tool augmented in various ways. And this development, this work is happening somewhat away from the public eye. We don't really know what companies are doing with these new abilities. And while everyone is distracted by chatbots and probing what questions they can answer, a true AI milestone has been reached somewhat away from the media spotlight. And that milestone is that we now know, not just in principle, but with tried and tested methods, how to train a large language model to independently explore, decide on, implement, and execute solutions for high-level goals, more or less in the general case. And this is the aspect of this that no one saw coming. So I've put LLM in this last paragraph in inverted commas, because can we really still call this a language model? Or would it be more truthful to call it something like a general self-programming AI platform? We've gone way beyond what I initially described to you as a language model, which is a probability distribution. So the real story is not psycho chatbots. It's not the AI apocalypse. I still don't think there's a plausible path to anything resembling AIs becoming more clever than humans and therefore doing harm. Those are not the real stories. The real story is that very large language models trained on what's near enough now the whole of the internet are far more powerful than any AI practitioner could have foreseen. If they tell you they foresaw it, they're probably lying. And with tool augmentation, large language models can, in principle, now interface with and control any system that has an API, including those that have real-world effects, both online and in the physical world. So what this has created is a radically new AI landscape with multiple urgent issues, including the huge environmental costs that comes with training and running these massive language models provided now as a service. And as they are provided as a service, we have no exact knowledge what exactly is under the hood. The companies, OpenAI, etc., they have been quite sparse in the information they've been willing to share exactly of what technology is under there. So the power over these language models, the control has ended up in a small number of commercial hands with no regulatory oversight whatsoever currently. There is now consensus, I think, broad consensus across the tech sector that we do need regulation of some sort. As I said earlier, tech leaders are calling for it now. But what kind is the appropriate form of regulation? We have the AI Act now, but how enforceable is that? How practical will that be? Will it have teeth in practical application? And as ever, the tech sector is worried about if we introduce regulation, will the progress happen elsewhere without us? There's also still the problem of built-in biases and the resulting harm from discrimination in the real world. That's magnified the larger language models get and the more widely used they are. It's a challenge also to understand the opportunities and risks in a fast-moving sector and how to manage the impending societal impact, which I think we can expect to be very substantial. So within ADAPT, we're uniquely placed to tackle these challenges. And that is because we have worked on language modeling since, as Dave was saying earlier, since the 1990s and 2000s, and on modern neural systems for MT since 2015 and 16. We have a specialized working group specifically looking at these challenges that I've just outlined of large language models, and we're building on a track record to carry out diverse current research with academic and industry partners on the foundations of large language modeling, including training and fine-tuning techniques, applying these to numerous application areas, including health, smart manufacturing, speech, etc. We're also working on making large language models more responsible and greener. And we have a few posters about each of these topics. And we do a lot of public engagement as well concerning AI and large language models. So in my own research group, we're doing a lot of work currently with large language models in PhD projects, industry collabs, research projects, including a controllability of LLM. You may have heard of the issue of hallucination, which I believe John Keller will pick up in his talk later. So how do we avoid that? How do we control large language models? We're also looking at the efficiency of large language models and how to improve it. And we have a poster by my student, Mohammed Sabri, back there on parameter efficient fine-tuning techniques. We're looking at language models for languages other than English, including Irish. And we're part of a large European consortium looking at how to create a European version of ChatGPT. We're also in the process of preparing an application for a large doctoral network on the challenges of large language models with a large number of industry partners and also third sector partners. And we have just started a new master's degree, Master's of Science in Natural Language Processing, which is starting this autumn, I'm pleased to say, with a focus on neural NLP, language processing, and large language models. Thank you for listening. Do we have time for questions? One or two? Maybe one. One, maybe one. Okay. All right. Okay. Would anyone like to ask the one question? Okay. Please go ahead.
If you don't mind, only one quick question. So, empirical, from what I've heard, probably in terms of scaling laws, an idea, a good threshold would be about 20 tokens per para. In your observations, were there any sort of ways of looking at training data, size of training data,
Sorry, could you repeat the question?
In terms of like empirical research, apparently, rule of thumb is the fact that in order to for good convergence, we need 20 tokens in terms of training data per para.
20 tokens per?
20 tokens
yeah.
per network parameter. And that scales nothing. So in terms of how much data do we need to train an good language model? Do you have any sort of hints in regards to data set sizes and all that compared to the model size? So definitely for a larger model we need much more data, for a smaller model, a bit less data?
I can't give you a rule of thumb of I'm not sure that there's agreement on how exactly the amount of training data relates to size, because you also have to take into account the architecture of the model. That makes a difference. But certainly the large base models that I was showing in the emerging technology stack, they're trained practically now on the whole of the internet. So it's absolutely masses of data. And it's only when we reach that scale that we have these amazing additional out-of-the-box abilities. So, oh, thanks. Okay, thank you.
Thank you very much, Anya. I think probably in John's talk later, he might pick up on some of that sort of availability of data for training purposes, and probably Rob on the panel as well. Anya, thank you so much for that. So next up, we have an interesting insight into how LLMs are revolutionizing the way we work. Paul Barnes is Group Engineering Manager with Microsoft's European Development Centre here in Dublin, and his team is building state-of-the-art products and services that leverage AI and NLP, and it's known as Microsoft Editor. So I'd like to hand over to Paul now and give you the clicker and wand.
Thanks, Declan. Okay, so I have a lot of stuff to do, and I believe we're running behind time. So I'm going to talk really fast, partially because of the time, partially because this stuff is so exciting. It's really incredible to be here to talk about it. We'll see how we get on in terms of questions at the end. So my name is Paul. I work for Microsoft. My backstory, and there's some thinkings out of this. I originally started by studying computer science back in 1989. I did an internship which brought me into industry. I worked for Lotus Development. I built printer drivers for 123 for DOS, if anybody's got a memory that long. I graduated, rejoined Lotus, and then I worked for Microsoft originally in 1995. Had a great time, really enjoyed it. But another opportunity came up for a company called Visio, which I joined in late 96, working on localization tools. We think about language, we think about the number of languages. We worked on projects to bring localization of our software for Visio and for Microsoft in upwards of 100 languages. That's a concept that we'll see across maybe some more of the slides. However, in 2000, Microsoft acquired Visio. So that revolving door brought me right back into Microsoft. And fundamentally, I've been a dev manager, an engineering manager, a group engineering manager, the same sort of role since 2000 and inside of the Office team. So two learnings there. First one is careful on exit interviews. When you come back, you want to make sure you can come back in cleanly. But joking aside, when I studied computer science in 1989, some of the concepts we're hearing about today were in existence back then. This is not new concepts. What is new is our ability to execute against those concepts. We can now do things that we could only dream of back there. The expression I love is what was once science fiction is now just science. So I'm going to talk about Editor. I work in the team called Editor. It used to be called Natural Language Experiences. I'm going to do something that I actually hate. I'm going to read out exactly what it says on the slide. I know everyone can read it, but the words are kind of important. In a couple of slides, I'm going to do this. So Editor is your personal writing assistant, helping you produce the best content possible in Microsoft apps and on the web. That's an interesting, every single word in there is carefully chosen. I'm going to give some examples of how this comes to be true, because there's a history into where we are today from our past. It also struck me when I thought about that mission for the Editor team, how aligned that is with Microsoft's corporate mission. Our mission is, again, I'm going to read out the slide exactly. I'm going to do this 3 times, apologies. Microsoft's mission is to empower every person and every organization on the planet to achieve more. When you think about the previous mission statement that we have for Editor, fundamentally, it's the same thing. We just want to do it when people are creating content and writing things down. So we're very much aligned with where the company wants to go to. And when I think of the scale here, it's really incredible. We want to do this for pretty much the entire planet. And that's one of the things that's important. How are we going to do this at scale? So some of the work that the team in Dublin does, and again, I'm painting a history of how we get into the space of AI. So we build several things out of my team in Dublin. First thing is Editor services. So we have these hyperscale, highly reliable, low latency and low cost services that power a bunch of scenarios. And I'll show you some examples of these so you can kind of see how this works. The atomic cost, the point at the bottom, right at the bottom there, fundamentally what that means is as our scale increases, the cost of processing each individual atomic transaction goes down. This is, for anybody that works in cloud services, this is like incredible to be able to do, how you increase scale, reduce your cost, maintain high reliability. And for something around natural language and text creation, it has to be next to real time. So getting these all to balance, because there's some mutually exclusive stuff that goes on there, getting them all balanced is a real challenge. Context IQ. I'm going to mention something a couple of times today. I'm going to mention the Microsoft Graph, because we see the capabilities of this space as a union of large language models and some other things. So the Microsoft Graph is the underlying infrastructure that connects everything together through Microsoft 365. Think of this as your inbox and the inbox of everybody in your organization, and those document libraries where you store documents in SharePoint, and your calendars and your contacts and your tasks. All of this information is connected together in what we call the Microsoft Graph, and it's secure and it's compliant. For example, as an individual, you only have access to your stuff. And as an organization, you can only draw on stuff from inside your organization. Nobody outside of the organization can use this. This is going to be really, really important when I get into some of the examples we're working on in a minute. On the far side, which would be the right-hand side, I mentioned in our mission statement about Microsoft apps and the web. We've built capabilities that we roughly brand as Editor, and we've built a browser extension for both Edge and Chrome, so we can bring those capabilities into line of business applications and into the web. And I'll talk a little bit in a minute about how that works. And then, of course, you're going to hear the term CoPilot. That's the brand name that we use for all of these AI scenarios that we're going to bring to our customers. It's a very deliberately chosen word, and again, I'll go into why that's so. So, okay, I'm hoping most people are going to recognize some of these examples. Everything I showed in the previous slide is encapsulated in a lot of scenarios here. So one of the most recognizable things that my team produces is the spell checkers that empower Word, Outlook, and the various applications. So simple things like checking the cat is in the hat is misspelled, and then giving you synonyms so you can choose the most appropriate suggestion for that. Grammar checking as well, checking whether you've used the right arrangement between subjects and verbs and sentences in various parts of speech. But we've gone beyond that. Originally, these were kind of rules-based things. For example, a spell checker is fundamentally an optimized dictionary, a flat list of things that you can go validate things against. That's where we started out. That's very much our history. Things like grammar checking is when you break a sentence down into its parts of speech, you can then check the structure between the various parts of speech and make sure that they make sense. Rules-based. Rules-based is very, very limiting. As we move forward thinking of things like deep learning, machine learning, AI models, you can get far more dynamic because language is so dynamic and so diverse. It changes pretty much every day. An example of where we use something beyond a rule is the example just here, where we used a neural network model to understand inclusive text. So if you look at the sentence, I worked with a policeman to fix the problem of security. That's non-inclusive language. If you're sending that in a really important document to a large audience, your chances of upsetting and offending people is potentially high. And so if you use the term police officer, it's a more inclusive term. This is just a simple example of how language gets very much embedded into how we share information, how we communicate with each other. This uses, as I said, a neural network model. And as we think of the evolution from rules through deep learned models to broad AI models, it shows how our opportunities for helping people along the way can improve. Now, this isn't necessarily wrong. It's open to debate whether people would consider this to be an error or not. Grammar checking typically is errors. Spell checking, typically errors. You can just, enforce those, but you can also give people insights into their language choice as to how effective they're going to be in communicating that message. I talked about languages. So this screenshot here shows that we actually have capability in 92 languages. As you go down through the various scale of languages, it becomes harder because you don't have enough data to be able to produce the same scale of models as you can for top tier languages. So we have challenges around some of that stuff. We're working on that. And also you get dialects. So as you can see from the screenshot, there are various dialects that we use in there. And other things, different types of writing. So we handle things like formal writing, professional writing, casual. There are styles and various nuances, and we build other capabilities into the editor feature set that does things like checking for acronyms for the sake of argument. I have a couple of examples of this, but people should probably recognize a lot of this capability. So here's a quick example of how you can actually use it. So imagine I'm working on an imaginary project and with an imaginary timeline. I'm going to start on the 1st of January. Good to start a new year with a new project. And we're going to start work, and maybe we have a proof of concept build, and we have a first test build. We go through code complete, zero bug build, and release to the web. It conveys the meaning, but it's fairly boring. And we can understand the structure of what we're actually saying here by using analysis of, this is a very simple example, but using analysis of the words that are being used to create a far more compelling representation. It's the same thing. It just looks far more compelling and easier to understand. And this is an example of where some of our earlier models would just detect this through a feature in PowerPoint called Designer and create a more compelling representation of this. This is going to be enhanced so much as we think about what large language models are supporting. Another example, and this is where the graph comes in. So I have a sentence in the top here that probably will make no sense to anybody in this room apart from me. I work in NLX with some PM and SWE colleagues. I'm guessing most people aren't going to understand what that is. In fact, some people in Microsoft won't understand what that is either. But we use 3-letter acronyms and we use these code words so pervasively in organizations that we just expect everyone to know them. One of the things we can do is through all my emails and all those documents I have access to in the Microsoft Graph, these terms have been defined for me somewhere. I might have got an email with them in it, or I might have had a document with them in it. And we can actually help you. So the first time you see them, we call the decoration of the text, we call that squiggling, red squiggles, blue squiggles, purple squiggles. It was so hard to actually decide what the colors were to get the right message across in the shape of the squiggles. But anyway, I digress. So the squiggling, we can squiggle the first instance of an acronym if there is a definition for that acronym, and we can allow you to right-click on it and then choose the actual term for that term. So, for example, NLX stands for Natural Language Experiences. Now, this is unique to me. It's feeding off of the data that I've received, not anybody else. So it's very much contained for myself. For PM, it could mean product management, could mean physical machines. I've had both of those definitions sent to me over time. For SWE, it could stand for Society of Women Engineers, Software Engineering, or Software Engineer. It gives me those hints and I can choose them. And when you choose them, it'll convert it into the sentence at the bottom. I work in NLX, Natural Language Experiences, with some PM, Program Management, and SWE, Software Engineering colleagues. Now, you notice the second time I use those terms, they're defined in the document. I don't need to do it every single time. I just do it the first time. And this is a great example of where the graph, the intelligence you can get from the graph, can actually help you convey meaning in a much more consistent way. So let's talk about CoPilot. This is the exciting stuff. CoPilot is a brand name we use in Microsoft for all of our investments in artificial intelligence across all of our products. We have a vast product range and we use the term CoPilot. That word is very, very deliberately chosen. Let me go through. Again, the last time I promise I will read out the contents of the slide. So CoPilot is your co-pilot for work. It combines the power of LLMs with your data in the graph and the Microsoft 365 applications to turn your words into the most powerful productivity tool on the planet. Again, tied in with our mission to empower every person and every organization on the planet to achieve more. We believe this is one of the ways we're going to do this. And those three things are important. It's the union of the large language model. It's the union of the graph. And it's the extent of being able to plumb this into people's lives through applications like Word, like Outlook, like PowerPoint, being able to bring this right into this vast number of people. The term Copilot, I said, is super important because we heard in the last presentation the concept of hallucinations. And we know there are challenges with large language models really confidently suggesting factually incorrect things. I'm trying to use the right terminology in this. So the concept of Copilot is exactly as you might imagine. As the user, you're at the controls, you're in the driving seat. Copilot will sit beside you, helping you to achieve your tasks. Now, you don't want to leave it unsupervised. You want to make sure that you agree with what it says. And you want to make sure that you're still in control, because at the end of the day, you're the one that's creating the content and sending that content out. But you really want to be able to have it sit beside you and help you with a lot of the work to do. And we're building lots of tech and lots of measures to help that be true. So the term Copilot is super important for what we're doing. So let me show some of this stuff. And this is where I need to use the mouse. Ideally use the mouse. Aha. This is a PowerPoint feature, by the way. I have goosebumps right now. Every time I watch this, I get super excited by it, because if somebody had told my 21-year-old self back in the 1980s, coming out of college, you'd be working on stuff like this that has the impact that it does, I would have probably struggled to believe that. Thanks. Okay, so let's just go over what we just saw there. What we saw were large language models in play in common applications. You probably saw Word, you would have saw Outlook, you would have seen PowerPoint, you would have seen Teams, you would have seen OneNote, all of the applications leveraging this capability and doing it in a unified manner. You saw leverage of the graph data. I've spoken about the graph a couple of times, and this screenshot at the bottom is a great example of that. Create me a press release based on this other document. Create me a press release based on this PowerPoint deck. Create me a PowerPoint deck based on this white paper, or vice versa. Pulling that information from the graph, when we think about, we heard earlier about prompt engineering. So the question you ask defines the results you're going to get back. But that's super important, and we're spending a lot of time thinking about that. But if you can give factual context into the model, like real data from your organization, real product plans, real schedules, real financials, and you can add that in, the results you're going to get out are going to be much more relevant and factual as well. So leveraging the graph data is super important. What you also saw in some of it was iterations. For example, this guy where you say, if it generates, and again, this ties into the term CoPilot, if your first attempt of the content, you read it and you just don't feel good about it, ask it to do it again, and it'll go generate a different set of results. Or maybe you just don't like the style. Maybe it's a little too formal, or maybe a little less formal. Maybe it's too concise, not concise enough. You can say, go create this and refine it in whatever direction you feel it wants to go into. Brings you to a thought. People often have asked me the question, various interactions about working on Office and on Word. I'm working on a word processor, kind of like the concepts of some of the artificial intelligence. Word processing's been around for a long time. Are we not done yet? Like, is that not a solved problem? And the honest answer is no, absolutely not. And why that's not true is, you think about what you're trying to do, you have a mental image in your head and you want to share that with people. So you're going to write it down. You're going to put it in an email, you're going to put it in a document. How many times has everybody here tried to do that, and the approximation in the words they get is close enough, not quite what they want to say, but you know, it'll do, it'll be fine. And then let's imagine we send that to 20 different people. Let's imagine 15 of those people read it. I know it's a high number, but we'll assume 15 people actually read it. What they're going to do is they're going to look at those words and the imagery and tables and whatever it is, and they're going to reverse engineer that into a mental model. And what you've got there is 16 different mental models. Now, we think union of all this stuff is going to position us to be able to enable people to do that much more. It'll probably always be a bit lossy, but we think we can do much better than we've been able to do so far. And the last thing you saw is cross-app capabilities. Turning a document into a slide deck and vice versa turns out to be a pretty complex problem, and large language models can really help with this as well. So thinking about that and the kind of idea of content generation, you also need to think about what are the modes for content generation. So we're thinking about these amongst other things. The first thing is, when you start with a blank document, you know, when you do File New and you get that fairly intimidating white page just looking at you, and it's kind of, oof, what do I do now? Like, what structure should I put in? Invoking a large language model at that point can get you started really quickly, really good. And you can ask it using prompt engineering. You can ask it for exactly what you want. Write me 4 pages on the use of AI text generation, and it'll create a structure that'll get you bootstrapped. That's a tough problem for a lot of people, getting past that initial stage. Another example is, people have probably experienced writer's block. So you've created a document and you want to add some new structure to that, whether it's an email or a deck, or it's a book, and you want to add a couple of extra paragraphs. But you just can't think of what's going on. What's the next thing you got to do? You can pass the context of what you've written already up to a large language model and say, go create the next step. And it may not be exactly what you want to say, but it'll definitely unblock you and get you kind of thinking in different directions. And then there's other things like rewriting stuff. If you've written a paragraph or a couple of paragraphs or a load of paragraphs, and you want to change the tone, the style, or other properties, things like finishing your document. Do you want to add an auto summarization to the start of your document? Do you want to add an executive summary to your document? And reviewing documents. So when you've got the entire document written, review that. How many people have read documents where they can almost see the organization from the document because multiple people have authored it, and you can almost see every individual person because of the way they've used the language for those particular sessions, for those particular sections. We think we can do a great job in actually helping those. So there are multiple, and this is just some of the life stages of a document. If you think about a PowerPoint deck, it's got different stages. If you think about business proposals, you probably go through multiple iterations. And we think large language models can augment the human creativity to actually make all of these integrate much tighter and much more seamlessly. And we think we're well positioned to execute against this, fortunately. We think Microsoft, I feel has got a lot of advantages to help us to do this. First thing, four main things. First thing is we have top quality technology. So we've heard, everyone knows about the OpenAI models, ChatGPT. They're not the only gig in time. There are lots of models coming out, but we feel we've got access with your partnership and investment in OpenAI. We feel we have got good access to one of the state-of-the-art models that's in the industry today. Second thing is wide reach. When we look at our users for Office products, we're talking about hundreds of millions of users and upwards of billions of users that use our products every single day, every single month, every single year. So bringing this capability into all those people's lives gives us incredible reach. I talked about the graph. This is the secure, accurate context. So being able to pull fact from your organization, from your personal domain, from your organizational domain, and bring that in as context to augment what we get from the large language models should result in much better results coming out the other side of them. And then the last thing, we have an internal expression in Microsoft. Microsoft runs on trust. And we're going to hear this loads of times. I've heard it several times already. We're going to hear it loads of times today. We need the AI to be responsible. We need customers to trust it. We need customers to have faith that it's going to do the right things for them. At the minute, we use the term CoPilot. We need to get to the point where you potentially don't need so much of that CoPilot and you can switch on autopilot perhaps. Nobody in Microsoft has vetted that term autopilot, so I'll say that for purposes of clarity. And we have a set of components called Responsible AI. It's an internal set of components that we build, that we integrate from day one, that helps us mitigate against some of the challenges that we see with embedding large language models into the hands of hundreds of millions of people right across the planet. But of course, there are challenges. There are lots of challenges. And that's the exciting thing about this. We're really at the advent of something truly transformative here. These are some of the challenges. They're not an exhaustive list. When I talk about reliability, responsible AI, compliance, privacy, you've only got one chance to get that wrong and you're toast, so to speak. If, for example, we were to take our organization's data and use that to train our models, that would be a complete breach of trust on our relationship with the customer. We're asking, as a company, we're asking our partners and customers to trust us with the stewardship of their data. They're some of their most important assets. We're asking them to store in our data centers and trust that we're not going to do anything nefarious with them. So we take this super seriously. It's one of the most guiding things we do. I talked about Microsoft runs on trust. We have lots and lots of internal trainings to make sure that this is a message we just don't lose sight of at all. Because as I say, you've only one chance to get it wrong and then you're totally toast. Capacity. Just think how much capacity we need if we're going to have 400 million daily active users calling into these large language models, which are big and expensive and challenging to scale out in that number. These are real problems that we're working through and solving on a daily basis. Speed of light, everybody knows this. The rate with which these features are changing is truly incredible. In my career, which as you've seen is quite tenured, I've never seen stuff move at this pace. It's lightning speed. For example, we have worked on some features over the course of the past couple of months, some of which we consider legacy. Inside of a couple of months, features we've built are out of date and kind of not as relevant as they were a few months ago, because the pace of change is incredible. And that's tough to manage your way through. Understanding what's important and making the right decisions in such a fast moving space is incredible. Somebody joked earlier today, it's highly possible, but by the end of this particular meeting today, that the world has changed. And we need to adapt to that in real time. Cost. Cost and capacity are hugely interrelated. It's not cheap running cloud services. Anybody that works with cloud services know they're expensive. There's cost around ingress, egress, compute, and various other things. These data centers tend to be have an underlying cost for all that infrastructure, maintaining and running and affecting all that infrastructure. So cost and capacity are somewhere interrelated. And this is why the stuff I talked about, the editor services, is super important. We spent years trying to optimize services and bring them into a very cost-effective pattern. Now, the tech for the large language models is different, but the concepts, again, are the same. We're getting more out of every single CPU cycle means you can do more on the same physical hardware, and also it costs less. And there's other things like knock-on costs or knock-on considerations, like the amount of greenhouse gases that are produced by data centers. If you can do more out of every single thing, then you reduce some of those as well. And the last thing is consistency. So we also use we've also used a kind of approach of planting multiple seeds and letting them all bloom. And that's great. If you think across the Microsoft portfolio of products, we're building scenarios, some of which are application specific and some of which are consistent. But this is a large organization with large teams and lots of people contributing together. So making sure that everything makes sense from a consistency perspective is a challenge to do. And we spend a lot of time trying to make sure that we're synced, but not limiting the pace of innovation. There's delicate balance there. And if you think about an industry across all the various pieces of various companies that are investing in this space, and also academia and all the government legislation has to come in to handle this, getting consistency across something evolving this fast is a challenge. Okay, how am I doing time-wise? Okay.
Very fast.
And I did say very fast.
We've got to set up the panel, so
Okay.
one question.
Okay. One question. This gentleman has his hand up first.
Great presentation.
Thank you.
For CoPilot, why you and a lot of other people are excited about it. If I'm an Irish software company looking to piggyback or kind of leapfrog off where you got to CoPilot, what's the roadmap? Is the architecture there? What areas should I be looking at?
Great question. So if I get the question right, just so I'm clear, it's how can organizations outside of Microsoft leverage some of the stuff that I demonstrated there? Well, Office is an open platform in multiple directions. Firstly, the file format's an open file format and a standard. So any company or individual can build something that can interact with that and interface with that open file format. So, and also there are object models for driving the application. So the very first place I'd start on that would be to look at those kind of well-established touch points for working with the applications, driving them either through automation or pulling in stuff from the document that you've gone and created. So that would be my starting point for that. Okay, thanks.
Thank you, Paul. Okay, so thank you for that, Paul. I can't wait to get started, actually, myself. There's a lot of useful prompts in there, not least CoPilot, write me a budget proposal for a research project. Okay, so we're delighted that Jonathan McRae is joining us today. He's chairing our first panel discussion. Jonathan is the host of News Talk's flagship science and technology program, Future Proof, and also a multi-award winning science and technology broadcaster and founder of WhipSmart Media. So our first panel today is focused on AI and its impact on industry.
Thanks, folks. You're all very welcome. We're just going to mic up Mary. Just a bit about myself. I'm a broadcaster, but I started off my career as a technologist. And I am an early adopter of technologies. I've always been fascinated with AI. Proof of a point is that I asked ChatGPT where I should go on my summer holidays. And in July, we're going to Albania. So I'll let you know, that's a true story. Well, I'll let you know how that goes. So this is a really fascinating day because we're looking at this incredible technology that sits in front of us and the opportunities for innovation, for exploration, and huge productivity. So this is a panel where we're going to be looking at the disruptive impact that this technology can have and some of the opportunities. I'm delighted to be joined by Louis Smith. He's Director of Product Generative AI Tooling at Shutterstock. Dr. Mary Coughlin, she's a partner in EY based in Dublin and the Irish firm's leader for health data and analytics. And Robert Ross. Dr. Robert Ross is a senior lecturer in computer science at TU Dublin. He's academic chair of the Industry Engagement Committee of ADAPT, and he leads the Controllable AI Special Interest Group. He's a funded investigator here, so he's got a lot of hats. So let's get straight into it. Louis, tell me a little bit about your role and how AI has sort of transformed it in the last number of years, certainly not a number of months. It's been a very interesting time for you.
Yes, indeed. So hopefully most people here know Shutterstock. It's that wonderful website. If you find a picture that you really want to download and it'll have a watermark on it, because we sell pictures. We also sell music, video, 3D objects, and so on. So we're a creative marketplace for anyone who needs content of any kind. And there's a big office in Dublin. And up until last summer, I was leading on search there. And since last summer, that focus has shifted almost entirely to generative and AI. Now, we always did AI, but we really ramped up the pace last summer when it became clear that the entire industry was moving at a faster pace and we needed to keep up.
There was a moment where you were told we need to do this now, right?
We need to do this now. Yeah, when we started to see image generation from our OpenAI partnership improve at a pace that we were expecting to take 3-4 years, happen in 3-4 months, we knew that our industry was about to be disrupted much faster than expected. So there are two teams in my division. One uses AI to assess content coming in. So photographers uploading lots of images, of which we're getting more than ever. And I think that's it's easy to forget that AI is moving fast and on a number of different tracks.
Yeah.
But then the other is the image generator tool. So we have a tool now. We have partnerships with OpenAI and LG and a number of other big players. And we have an image generator tool which launched in January. What's good for this community here is that there's a big Dublin story. So the team built it is based between Dublin and London, and they are currently working on a design assistant and some text creative assistants as well. So lots of good things in the works.
So just to dig a bit deeper into what Shutterstock's doing, you're buying images that have been generated through AI. Are they tagged as such? Are you separated saying this is, when someone buys an image, do you say here's some AI stuff and here's some non-AI stuff? Or how do, if I'm looking for an image, how does that experience trickle down to the consumer?
So yeah, so we're quite unique. So our business has always been, we have hundreds of millions of pictures. You download one, we give a little bit of the money, we charge you, and we give a little bit of the money to the photographer who uploaded it. In the new world, we are able to generate pictures. So if you have a specific creative need, you type it in, and we will generate pictures that hopefully will meet that need. If you download one, again, we charge you, and the money, that royalty payment, instead of going to one photographer, it will go to what we call a contributor fund. So it goes to this pool of contributors who all provided content that was used in the training model that is actually generating images.
So it's kind of like a Spotify model.
Very close to Spotify,
right.
Yeah.
Okay.
So if you're on the photographer side, you're getting like fractions of pennies for every individual download, but the hope is that over time this will scale up and that will become a significant portion of income.
By the way, I met someone on the train here this morning who hadn't heard of ChatGPT, so I want to make sure. I realize I am in a bit of a bubble, so I want to make sure everyone understands when we're talking about AI image generation. Just raise your hands that we don't need to explain that. Raise your hand if you understand it. Okay, so okay, so it's pretty much everyone in the room. You type what you want, you just say the sentence, a man in a cloud, and then it'll make a picture in various styles and so on, right?
Yeah, exactly. And so we got very excited because originally we thought this is going to be cool because sometimes people come and they search and they want a rainy street in Paris with an orange car, and we don't have, despite having 500 million photos, we don't have a photo of an orange car in a rainy street in Paris, and this could fill that niche need. Now, that happens, but that's not the main use that we're seeing. So the main use we're seeing is people using this for storyboarding, ideation, prototypes, and any kind of like creative use case that you have that is a little bit more offbeat, right? So you say you need a book cover, or you need some visuals for an album or music and so on. Our first ever license from an enterprise client came in, and they tend to be like sort of quite high dollar values, so they get a lot of attention internally, especially. So the first one was a bit of a landmark, and we saw the picture came up, and we were like, it was this sort of floating pyramid, and there was like this tree, and there was like a rainbow, and we were like, who? Like,
what was the prompt here?
Like, what are they trying to achieve? That this is the solution, and that they want to license for thousands of dollars, and it turned out it was a cannabis dispensary company in the United States that had a creative message that was not being met by any of our existing content.
I see. Okay. Very interesting. So we're talking about how this world is changing so fast. Since we spoke, which was what, 2 weeks ago, 3 weeks ago, we've seen Photoshop generative fill, right? So the public has seen, you probably knew about it.
We have a way cooler feature.
All right.
Yeah. Which we call Zoom Out.
Okay.
That we released first.
Oh, right. Okay.
Yeah. And you can zoom out on an AI generated image on Shutterstock and license it today, and for commercial use. Whereas some of our competitors will have offerings.
Oh, he won't even say the name. He's been well trained, this gentleman. Well done, Lou.
Our competitors have released things that, if you read the fine print, they are still leaning on language around it. It's a beta, and it's not available for commercial use.
Yeah, no, I know. Look, this wasn't a dig, but I guess my point was, that added an element to image generation that I hadn't really thought of. And before we kind of move on, like that sort of additionality of creating around pictures that are already there. Are there other things that you are looking at down the line that you think, when people see this is going to be really exciting? Because that to me was really about the very playful tool, because I've seen some of the memes on I'm conscious I've got my back to you guys. Some of the memes around filling out album covers and using generative fill to see what the AI thinks the rest of the album cover is, which is very funny. Are there other things on the horizon that you're excited about?
Yeah, there are. So zoom out is a nice clean functionality that you can ask the machine to, here's a picture of the Mona Lisa, zoom out, right? Let's see what's behind it. But if you have,
is that based on what's actually in the Louvre, or is it based on what the AI, when it looks like, for like the same way photo fill, like will it look at previous photographs from user data that that have taken wider shots of the? I'm getting quite. Is this okay to be going a little bit deep here?
So it's about generating plausible.
Okay, yeah. So it's a mix of what might be there, but also what it's.
It's about generating a plausible canvas. Okay, right. That's what a plausible canvas that matches the request of the input, the text that you input. Okay. Now, what we will have when we have a design assistant in the coming, I mean, it's already in alpha, is that you will have a picture, and the picture might be a dog running on a beach chasing a ball, and the sun in the background, and it looks great. But the dog is the wrong type of breed, right? Now, you might say, okay, let's have the dog chasing a frisbee. We want the dog to be a Labrador instead of a poodle, and we want it to be chasing a frisbee instead of a ball. The sort of the easy way to do it is, right, you give the people some tweaks and dials that they can, like, scribble out here, replace this part with a frisbee, scribble out here.
I've done that hours and hours, right? It's such a pain.
Such a pain. We have all the pieces stitched together, and we can stitch them together. We are stitching them together, that you say, make the dog a poodle.
Nice.
Or make the ball a frisbee. And we use the language models to parse that into a set of structured requests that we say, okay, find a thing in the picture which looks like a ball, select that area, use that area, what we call a mask. So that kind of, it's where we generate just within a subsection of a picture, use that, and then do another generative process where we generate an image and we're stitching in the frisbee. And we'll do the same.
Man, that's exciting.
And so Paul mentioned earlier the CoPilot brand. CoPilot is such a wonderful brand for describing what these things do, because it really does feel like you've got someone sat next to you there, your assistant or your CoPilot, that you can say, okay, swap out the ball for a frisbee. Let's make a sunrise rather than sunset. Let's make the beach more French.
Okay. We'll come back to you, Louis, in a second. Mary, tell me a little bit about your role. I know you're within healthcare, but not healthcare necessarily in the way people might think. So let me hear about your role.
Yeah, no problem at all. Well, firstly, I'm sorry that it's not going to be anything like as cool as what you've just described. Or exciting.
Saving lives, Mary.
Saving lives, yes, on a mass scale. So I suppose just a bit of background about myself. So I'm a medical doctor, but also I have a background as an actuary. So I'm kind of, in my current role in EY, I lead the health analytics practice, basically, which is kind of, I suppose, to an extent, combining hopefully the best of kind of both my previous worlds. So what does that actually mean? Well, I think in particular, since the kind of onset of the pandemic, data and analytics in health have really come to the forefront. The fact that beforehand I was going to say we managed, but managed will be too strong a word. We somehow survived without really bringing kind of these absolutely key assets into play in the way they should be. It was no longer an option once the pandemic hit. So since then, so basically for the last about 3.5 years, I've been kind of working, with various health organizations and helping them bring data. And in some cases, it's very, kind of very basic, kind of what is your data? What data do you have? How can you kind of bring it together? How can you use it in a really basic way to improve what you do, to more advanced health analytics, where we do predictive modeling, where we do prescriptive modeling, operational research type stuff. So kind of getting into the AI space, not anything like as cool as yours, again, can I reiterate, but really starting to kind of think and help organizations evolve their thinking around how they are going to use this kind of technology in the future, ultimately to improve health outcomes for populations.
Can you give me a case study or two?
Yeah, so one really interesting project that I have been involved with and have led is around, for example, a simulation of the full Irish health ecosystem. So a lot of the time when people think about when they think
digital twin.
Exactly. Yeah, exactly. When they think about kind of AI and health, they're thinking about things like, radiology and mammography and, those kinds of use cases, which are obviously really important and powerful use cases. I'm very interested in those, but I'm particularly interested in exactly a digital twin of the system. So we don't really understand, for example, something quite basic, as in we all hear in this country about, waiting lists, but we also hear about waits and numbers of trolleys in emergency departments, right? But we don't fundamentally understand how we have kind of scheduled care where people are planned to come in for procedures, operations, etc., versus, we'll say, emergency care, which happens throughout the year, but there's a particular surge in the winter. They interact with each other. But what is the impact of one on the other? In terms of when we have a surge, how does it actually impact on our scheduled care provision and ultimately on our waiting lists? So the work I have done, so that digital twin that the work I led on that was around understanding the interoperability at a whole system level of the various components: scheduled, unscheduled, outpatients, inpatients, community, hospitals. So that would be a use case, and basically stepping it out, simulating, day by day, week by week, the patients we expect to come into the system, what their experience will be from an operational perspective, i.e. how long they're going to stay for, what kind of level of acuity they're going to have, and ultimately then, what will be the impact on waiting lists, what will be the impact on hospital occupancy, etc.
My dad went to Vincent's on Friday last because he had some stomach pain, and it kind of went, and he saw someone, then they disappeared. And look, I mean, everyone knows nurses, I have to say that every time, nurses and doctors do a great job, but he was stuck in the hospital for 5 days after having, like, he did a bad stomach pain, but he was and people would come in, he wouldn't see any doctors, and it would just go on and on and on. And so there's a huge amount of efficiency lost in this system. So there's a huge benefit, I think, to everybody to do better with the touch points and with the scheduling. Who's pulling? Is this the hospitals pulling to get better efficiency in? Is it or is it a push from technology companies and EY saying, look, we can help you, because you have this idea that the Irish health system isn't the most innovative in the world. Are they, welcoming this with both arms, or are they sort of resisting it while you're trying to say, come on, let's go into the 21st century?
Well, it's a great question. I think it's a bit of both, to be perfectly honest. Like, the reality, unfortunately, is that we are very, very much behind the curve when it comes to innovation and when it comes to technology and kind of the digitization of our public health system in particular. And I suppose one of the fears I have, going on a slight tangent, is we will fall even further behind now, because the pace of change that this kind of technology is going to, effectively enable won't be possible, because we don't have the basic systems in place in order for us to enable it. So that's actually a real kind of sadness on my part, actually, right? I have to say. But to get back to your question, I think that I think that the system and the leaders in our system do want the change. I think there isn't a full and comprehensive understanding of what's required, of the investment that's required, and possibly a fear around that as well. And then we would love, I suppose, as innovators, to kind of support that journey. And certainly we try to do that. But it's definitely, I suppose, the kind of the size of the challenge makes, I think, or kind of causes fear. And of course, it all becomes a vicious circle.
Right. So, I mean, it's difficult to say, really. There's a bit of it all. Is that what you're saying? Or are you being just being careful, which is totally understandable as well?
No, I'm not being political at all, because I really do believe that that our leaders, we have actually some great leaders in our health system, and I believe, and some great innovators as well. But I suppose the size of the investment, the size of the challenge can be daunting at times. But I think, look, I mean, there's impetus. So, for example, there is a requirement by 2030 that we have a certain level of shared care records in this country. So that is going to give us a kick no matter what, because the fines will start to run into hundreds of millions if we don't actually fulfill that. So I think that...
Thank God for Europe.
What?
Thank God for Europe.
Yeah, thank God for Europe. But 1973 was a great year, right? So basically, so I think that I suppose so that is going to create, I suppose, tension in the system to force some positive change. But I also think, again, getting back to the kind of use cases that will be enabled by the technology that we don't yet have, do you know what's going to be the driver ultimately? The public is going to demand it.
Yeah.
Well,
we've been demanding a lot.
Yeah. Well, I think we're in a different space now.
Maybe.
Yeah, I think we are.
Robert, the speed. One thing that's really interesting about this particular. So I've been doing a science broadcasting for the last 13 years, but following technology, I was probably one of the first users in the country of many of the early communications technologies, from WAP to all sorts of different systems working in ocean communications a long time ago. And I've watched as, new technological and scientific advancements have come, and the academics have always been like, yes, we knew this was coming. What seems to be really different about this is even the academics were surprised in September. Even the people who are, were lecturing on large language models were like, what is going on here? Tell me a little bit about where we are and what adapt what adapt can do to help people tackle what we're looking at the moment.
Okay, well, is that on? Yes. Let me start with where we are. So honestly, I still think we're at the very beginning of this. It is rapid, it is moving very quickly, but in the great scheme of things, and I've said this before at similar panels, we are in 1997 in terms of where the internet was. Suddenly the media is all about this technology. Companies are looking around saying, are we doing something on this yet? Invariably finding the answer is no. And there's a great deal of panic within a lot of companies, or to be more polite about it, there's a lot of FOMO, fear of missing out. And that's right there across industry. But on the technology side itself, we're still very early in the cycle of development of this technology. We saw from some of the speakers this morning about how there are many advances that we've seen, but there are issues such as the agentive nature of the technologies that we still need to really crack. We need to get the technologies into different applications, and fundamentally we need to see how this type of AI can be fused with and used with other types of AI, such as say in the automotive space, or such as in Internet of Things and sensor spaces, etc. All of that is still yet to come to a great extent. So does issues around personalization, so do issues around, as my colleague John Kelleher will comment on later, fixing some of the issues we know are there.
Yeah.
John is going to do a pretty good talk, I think, on issues about aligning the models with what we consider to be good qualities, such as truth and ethics and getting things right, which I think is fair to say that we need to be able to rely on. So we're still at an early stage, and I think we're going to see a huge amount of growth and disruption within the next 5 to 10 years. I was listening to one of my learned colleagues from a university in Cork talking on Morning Ireland last week. And one thing I found very curious that he said was, this AI isn't going to take anybody's job. I think that was just utterly wrong. It might have sounded reassuring on the radio. We have seen over the years how AI morphs into normal technology and does disrupt the workplace. Now, it creates jobs, but it does cause some jobs, or at least some roles, to become defunct, or we don't need as many people in those roles anymore. So in terms of seeing how we're going through that technology roadmap, this truly disruptive technology avenue, we're still at the very start. To come to your second point, fortunately in Adapt, we're here to help you with your needs. All joking aside, as part of Adapt in our remit, we've worked with companies ranging from startups through SMEs to multinationals who have very, very big footprints around the world over the years in areas such as conversational AI through to the other tech that we're involved in. And we're seeing similar requests and similar proposals in terms of joint research, collaborative research over the last 6 months that we've seen previously. Obviously, there's a big focus now on the large language model and more generally the generative AI side of things. But there's nothing particularly shocking in terms of what people need. They need to know, and to use a quote from a company we were speaking to, they want to know about the guardrails. They want to know how, coming to the question that was asked earlier, where can they begin in terms of taking this technology and putting it into work in their organization. Yeah. And that is in part due to the FOMO issue I mentioned earlier, but it's also due to genuine opportunities being seen in the organization in terms of, oh God, we've got that really slow process. Can we take advantage of LLMs or generative AI?
I mean, it's a commercial imperative now, right?
Absolutely.
Yeah.
And so they're identifying these issues, but they have fears. And I think the fears are justified. The fears are big time in Ireland or Europe around the data. There are those scare stories going around of companies sitting down to use free versions of ChatGPT and so forth to try things out and discovering that they've leaked key company data into this language model API that they can't just get back. There's no undo button, as much as people would want there to be. So we're sitting down talking to a lot of companies about those issues and the training and the building of models, because it is, as was discussed earlier, a case that the models don't necessarily need a lot of fine-tuning. They can be used in smart ways to do tasks without changing the backbone model itself. But companies need the experience of how far can they go with that or do they need to look at fine-tuning issues, or what would that even mean in this space? So there are a lot of the questions that we're dealing with. But fortunately, we've got a great commercial team led by Declan McKibben, who is leading today, who is great at sort of trying to balance off the needs of the industry partners with that big pool of academics we have, including some of the ones speaking here today, but of course that much bigger pool that Adapt builds on.
What are the killer apps for LLMs, do you think? I mean, that we see now today, and just while you answer that question, in terms of time, I know we're a little bit over, went 10 minutes, including questions? We're stretching we're adapting.
I could have given my answer already.
You go ahead. Go ahead. Well, we'll figure that out. Great.
Okay, so I'll try to keep it shorter then. Although I did want to answer in 3 ways. For LLMs, I honestly think in terms of core LLMs, the type of issues we're seeing in Microsoft Office, in the CoPilot type technology, that's low hanging in terms of the fact that the teams are already implementing it, and it is going to completely change how a lot of office operations are executed. And I think we're going to see big changes there, simplifying changes that make things better. But that's just LLMs. For the conversational LLMs like ChatGPT and the like, I think healthcare is going to actually benefit a lot from it. But more broadly, people have said to me, where is this going to affect the biggest, the fastest? Call centers. Honestly, I think call centers are the low-hanging fruit where companies are calling out to try to simplify the processes, still making sure that customers have a good quality of service, certainly not removing the human in the equation, but maybe moving the lines in terms of where the automated call center process can help people before they need to be pushed up to the human in the loop.
Yeah.
So, and then finally, the other one, generative AI in general, low-hanging, not so much low-hanging fruit. I think the image manipulation stuff is huge. It's fantastic. I love playing with it myself. But also in terms of animation, etc., we're going to see huge changes where text prompts can be used to generate videos of characters walking through an area. We're going to see so many different areas of the creative spaces changed over the next few years. And again, we're just at the start.
Yeah, I saw last week one of the AI giants in America decided that they wanted to hire a prompt engineer, and the salary they were offering was $350,000. So there's obviously new jobs being created. Louis,
this is an obvious joke, but who is the company?
Anthropic. So Louis, tell me a little bit about the feeling of the content creators and your partners. How do they feel about this? Because one of the points that was made in our conversation is that it's not just your industry that's changing, everyone else's industry that's changing. And so how do the photographers feel about this oncoming change? How do videographers, designers, graphic experts, how do they feel about what's coming down the line? How do you keep them happy in a way?
So yeah, we have a very wide pool of creatives of very different kinds, and our photographers that we call contributors, right, or contributors on all our asset types, they are creatives themselves, and they are among our most engaged users and the most enthusiastic about AI. It's in the nature of someone who takes photos for a living that they also are and excited by a thing that generates photos, and it affects them hugely in terms of sort of what it means for their role. Obviously, it changes the landscape drastically, and it changes how we operate and how they operate, and it also changes what it means to be a photographer, right?
Yeah.
If you have suddenly this blurring of the lines between, there was a clear line before between sort of original content, let's say manually edited content, and then the synthetic, and now there's much more of a spectrum, and we have different platforms, different marketplaces landing in slightly different places around sort of where they draw that line between sort of the original and the synthetic. So among our sort of on the customer side, the text generation obviously is the more advanced, so that kind of gives us a taste of what is happening in image. And we know among like people who work in marketing who have to write text for a living, right? So imagine you have to write the words for different variations on ads, or you write blog posts with a very kind of marketing focus, or you write emails that go out to users as marketing shots. We know people have quietly started using en masse text generators, right, to do their job, because it's very good at taking away or automating intellectual legwork and creative legwork. There's still decision making, which the human has to do. There's still a human in the loop, but that legwork gets just automated away. So we know that has happened sort of across the board, and then you get to this point where companies just like buy the full subscription for some sort of like copy editing tools. We're seeing the same, but at an earlier phase in terms of image, and then we would expect the same to happen with 3D modeling, music, and video down the line.
Yeah. What about coding? Because your group is obviously a lot of coding in your work. Are we going to see? Because we're going to see zero code. I don't know. There's no code. It's not quite no code. It's close to it. So
I know multiple software engineers who have a tab open all day that will be a large language model of some kind for code. None of them, I believe, work at Shutterstock, or they're not supposed to, because for exactly the reasons you were alluding to, that there's a squeamishness about the blurred line between what is training data and what is just usage. And as you heard from the Microsoft presentation, there is a huge value in making that really clear. That's like, okay, you can use this thing and we won't learn from your data. But that's still kind of shaking out. So it's already very good for getting you from, let's say, kind of from 1 to 2, not from 0 to 1, right? If you tomorrow want to write a Python app using ChatGPT, you will need to know some Python. Maybe you do, but you would be able to say, write me a Python app that does XYZ, and it has a window here and a window there, and this window has these tabs and that window has these tabs. It will give you back some code. It will be almost right, and some stuff will be wonky, and then you'll say, actually, can you just like make that tab do that? And then it will give you the snippet that you would then need to copy and paste in.
Nice.
So if you've got basic skills, you can write a simple app very quickly. Have you ever, the old meme about how to draw an owl? Step 1, where you draw the 2 circles.
Yeah.
Step 2 is just draw the rest of the owl. And there's an element there that like, so it can get you to those 2 circles, right? Now you need to then have broader engineering skills to know like how to package that, bring it up, scale it to multiple scripts and so on. So getting to a place where you are able to put in instructions that are so precise that you have a zero code app that you've described everything it does. Well, you've just become a product manager for a start, because that's extremely hard to scope out requirements to that extent. And what you're entering then a world where that humanly described input is the code.
Right.
So there's still code, there's still work there.
Okay, so that sounds really, really exciting. I think I saw a tweet from a coder recently saying to use these large language models, people still need to know what they want. I think our jobs are safe, which I thought was a good one. Mary, in healthcare, knowing what we know about LLMs and the landscape where there's so much innovation potential, but there is that drag of, healthcare moving more slowly and regulation. Where are the opportunities for founders when it comes to healthcare? Where do you see a real opportunity to move fast and not break things?
Yeah, so it's really interesting to think about, I suppose, ultimately the kind of the low-hanging use cases in this environment. So I would think the health use cases for me can be split into 3 broad categories. The first one would be around the things like the clinical use, where you'd be, again, getting back to, your radiology or your dermatology, and effectively you kind of use the pattern recognition sort of a use case. Those will be slower because of kind of the requirements around licensing, clinic, overcoming the clinical hurdles, even around kind of clinical autonomy, all that kind of stuff, right?
Yeah.
But they'll still happen quicker than a lot of clinicians would like to think, in some ways, but I think they'll be a bit slower. Then I think the other use cases are two kind of broad categories where clinicians can be enabled on a day-to-day basis. Those are things like, and I was just even reading there this morning about a company in the US where they have already, they have a private provider where they are already, using the generative AI to basically, to input into their electronic health records, right? So based on an interaction between a patient and a clinician, it populates the electronic health record, which is amazing because it's the bane of many clinicians' lives.
Form filling is a boring but really, really exciting place for your founder, right?
Yeah, right. So, and again, the CoPilot idea being then obviously that you look at it and you make sure that you're happy with it all, but wow, it's basically done 80% of it for you up front. Of course, the problem we have here in Ireland is we don't generally have an electronic health record, right? So that is going to be, and that's where my fear is around like those are going to be really quickly adopted use cases if you have the enabling technology in place, right? So that's a real worry for me personally, I have to say. From an Irish perspective, where I see the low-hanging fruit and the use cases is around kind of the operational research and getting back actually to pattern recognition type stuff, right? Where, waiting lists. Okay, so we have lots of data in multiple sources about waiting lists. And again, we don't really understand. I know it sounds daft, but we don't really understand why we can't manage them, why they aren't behaving in the way we expect them to behave. Where's the capacity? Where's the demand? What's coming, right? So I see, and already I'm starting even to develop the use cases around actually improving operational efficiency.
Yeah.
And, that's actually a quick one, and I think, and by the way, can actually create amazing outcomes for our health system in the Irish perspective. And I suppose it's where innovators aren't reliant so much on the infrastructure within the health system itself.
Yeah.
You can use your standalone technology and you can kind of support, the health system using that.
Yeah, and you're not worried about FDA or EMA or that sort of stuff. Yeah,
exactly. Yeah.
Okay, I'm supposed to be good at this, so I'm finishing now, and we're going to go 5 minutes of questions. So we are on time as the time was given to me. So 5 minutes for questions. Raise your hands. Yes, this lady here.
Actually, you touched on this a little bit, and thank you for that. But in terms of the training and learning development, the skill sets that we see that are being required now in your industry, like creative, healthcare, for example, use of digital twins in terms of training the next generation of clinicians, right? And in education, I read a working paper where the most vulnerable jobs have shifted with generative AI, now hitting educators, especially secondary level and up. How do you see this all changing now in your perspective?
We might start with Robert there. The question was about skills for those watching online.
I think there are a lot of questions at the moment amongst educators, since you touched on that point, about trying to consider where this will impact. So when ChatGPT first hit the news headlines before Christmas, most educators seemed like rabbits in the headlights in terms of plagiarism. Everybody was discussing plagiarism. And in the end, that's not as much of an issue because we've been used to dealing with students and essay mills and so forth for years, okay? But the interesting issue and where things are now turning to is the question of the curriculum. What does it mean in terms of the impact of large language models, generative AI, ChatGPT, in terms of what we need to teach? Are there changes we need to make in terms of certain skills are not as applicable anymore because they're perfectly automatable, whereas other skills become more prominent? Do we need to prompt engineering? Do we need to incorporate that into our curricula? So obviously, coming from a computer science background, I'm able to talk about that more in terms of how we educate computer scientists. We have encouraged them to use CoPilot, has been there in terms of coding systems for a couple of years now, and we strongly encourage it because it's, to those in the profession, it's basically the equivalent of checking things on Stack Overflow. But when we move into other sectors, I think like healthcare, it's quite interesting. We're going to have to see how we can make sure that clinicians and other allied healthcare professionals are making use of these technologies to the best degree. But I also think there's going to be a lot more head scratching in certain other areas, such as in the arts and other areas of creative areas where the nature of the job or the nature of the skill has been about looking at a body of knowledge and synthesizing new knowledge or ideas out of it. Because in the end, that is what the ChatGPT style architectures seem to find relatively easy. So I think amongst some of those disciplines, we're going to see a lot more consideration of how does this change what we're going to teach and what we see the future workforce having to deliver on. Very good question. And I think, being honest, in terms of figuring out those skills, that's a process that's only now really kicking into full gear.
Can I get two sentences from each of you on that, please? Mary.
Yes, so I think that 2 sentences, so that's pressure. So
that's 1 sentence.
So I think it'll be up to innovators actually to lead a lot of the kind of the industry education around it. That's one point. The other point is the challenge, of course, as well, the pace of change also poses the question as to how and what exactly we should teach in this space. It's very hard to know how to teach people today for what they're going to be dealing with in the real world in 4 years. So I think that's a very interesting question.
Yeah, Louis.
So just like all of the other digital waves that have hit us in the last 20, 30 years, I think this is a set of superpowers that are available to anyone in almost any sector who has the appetite and curiosity to go work out how to use them. And you can use tools even today, and it will get better over time, to generate music unlike anything like that your clients have seen, or create pictures or edit pictures in ways that unlike any way, or operate at a scale unlike anything seen before. But my second sentence.
Yes.
Like all superpowers, it doesn't come for free, right? It comes at a cost, and that cost is there is an investment. There will be blind alleys and there will be disappointments, and it is possible to go down a rabbit hole forever and get lost in AI Twitter. Looking at top 10 amazing tools that will blow your mind.
Yeah, from robot
and they won't get to where you want to get to.
I'm going to break the rules and I have 1 more minute. I'm sorry, we don't have any more time for questions, but I gave a talk to students at my old school at a prize giving about 6 years ago, and I was talking to them about the future and how technology is going to change the jobs of the people in the room, and the lawyers were not very happy that I was saying law is going to be very different by the time you graduate. But what I said to people was, if you're a very technological person, learn something creative, and if you're a very creative person, learn something technological, because I think being able to understand how both types of people navigate the world will be a useful, broadly applicable asset. What a fantastic panel. Thank you so much to Louis, Mary and Robert. I'll hand back to Declan.
Okay. Well, thank you. Thanks, Jonathan, and to our panelists there. In the interest of time, I won't thank you all individually. So we have a 15-minute break for coffee and comfort break. So it's now 17 minutes past 11. We'll be back 11:30. Without further ado, welcome back. We're handing over now to Professor John Kelleher. John will explore the opportunities, challenges, and future directions for generative AI. And we're delighted to have another world-class leader in AI in the room, and a prolific author on the topic as well. Hopefully you'll get a chance to promote that. John is a PI in ADAPT, and he's the Hamilton Institute Professor of Computer Science at Maynooth University.
Thanks very much, Declan. Hi, everybody. It's great to have this opportunity to talk today. And I'm starting my timer here, so I'm going to try and stay on time. So I've got 30 minutes, and you can hear me okay? Yeah. So, great. So, oops. I think my title slide may have disappeared. But anyway, my title is the challenges, opportunities, and future directions for generative AI systems. That is a fairly vague title, all-encompassing, and that's because it was nearly 2 or 3 weeks ago that I was asked to give this talk, and things are changing so rapidly that I wasn't going to be a prisoner to fortune, as they say, and say I'm going to talk about X, because 2 days before you talk, somebody releases something and X is no longer an issue, or X is completely changed and your slide deck's out of point. So I thought, okay, challenges, opportunities, and future directions kind of allows me to do anything. And that's pretty much where we are today. Okay, so the main challenge I'm going to talk about, actually, there's a lot of challenges out there, but the main one I'm going to talk about is the concept, it's the challenge of hallucinations. Okay, and I'm going to illustrate that, why it's an important challenge. And in fact, actually, if you look at the GPT-4, OpenAI released a document, which is like their technical report on the GPT-4 model, the most recent model. And a very interesting element of that document is the second half of it is the system card, where they report on the challenges that they perceive in the technology and the mitigation. They report on the mitigation work they did against those challenges and risks. And the number one challenge they listed was hallucinations. Okay, so that's why I thought this would be a good thing to talk about in terms of challenges. There's lots of other challenges out there, you know, misinformation, disinformation, etc. But we'll talk about hallucinations. So to try and put in context what a hallucination is and why they're important, I've taken this image. I've sampled this image from the web. The source is down there at the bottom. So this is an example of a hallucination from Google Bard in February. So in February, Google launched Bard, which was Google's version of ChatGPT. And when at its launch, they put out this image here, okay, where somebody had asked Bard for a very nice, inspiring question, you know. What new discoveries from the James Space Webb Telescope can I tell my 9-year-old about? Okay, you would think that that is a very safe topic to launch a product on. You know, we're trying to inspire children to get into science. What can go wrong? Okay, and the system generated this output. All right, and you'll see that there's nothing offensive there. You know, there's no racial slurs. There's no biases. Again, what is there to worry about from a technology perspective and a brand perspective? You're not doing anything dangerous or harmful here, okay? The problem is that there is an error in this text. So does anyone know what the error is? It's point number 3, okay? The claim that the James Webb Telescope took the first photo of an exoplanet, okay? So well, stuff's fine, but that one there. So it generated a statement that was incorrect. It's false, okay? Now, again, what happened? What was the response? Well, Google shares lost 100 billion, okay? And shares plummeting afterwards, all right? So just to put it in context, why are hallucinations important? Well, I think that's the number there we need to pay attention to, okay? 100 billion, even if you don't do anything like directly harmful, you know, it's just like no one died here, okay? So that's why we think hallucinations are important to think about. Now, so what is a hallucination? I've seen many definitions from it. If you look at the literature, they're all slightly different. There's an but it's general. I did hear one definition, which is mansplaining. It's automated mansplaining, where a language model talks confidently about things it knows nothing about, you know. So that's one definition of hallucination. But generally, it's where the language model is generating incorrect or false facts, okay, and doing it in a very confident manner. And we were talking about confidence just a second ago. The importance of actually understanding the confidence of a model and its prediction is really important. That's another topic. There is some interesting discussion in the literature in relation to distinguishing between fact and faithfulness, you know, because it could be, for example, if you're to think about, if you ask the language model to summarize a document, okay, for the main points in the document, and that document that you give the language model has factual errors in it, okay, there's a decision to be made of whether the generated summary should be faithful to the source it was given, the actual document, in which case the summary would actually have an error in it, or whether the model should sort of correct those errors and the summary actually be factually correct, but diverge from the source. Yes, that's a distinction that happens here. I won't go too far down that particular rabbit hole, but just to be aware, in general, what we're worried about here is that the model is generating incorrect, false content. Okay. So there's many causes for hallucinations. One is around generalizing beyond the data. So what we're talking about here is you may have trained your model on a large amount of data, okay? You will have trained your model on a large amount of data, but you could still end up asking the model about a domain that wasn't in the data set. Now, the models are actually trained to generate the next word, you know, based on what's come previously, and it's very good at doing that, okay? And it will generate the next word. It will just keep generating the next most likely word given what it's seen before, even if it doesn't know the topic, okay? So if you start asking your language model to generate content on a domain it wasn't trained on, it will hallucinate the text, okay? And that's why so what Anya was speaking about earlier, you know, that three-layer approach. If you've got your underlying language model, then you have your instruction-based GPT, and then you have the final layer where you're putting the guide rails to make things safe on top. Why that can be so important, particularly if you want to have a language model tailored to a specific domain. You know, so you might take a large language model off the shelf, but then tailor it or fine-tune it to the needs of your company or your domain, okay? And that's one way to try and get rid of the hallucinations, by ensuring the model has been trained on the relevant domain that you're going to ask it about. Another aspect is the divergence between the training data and the prompt. Okay, and that example I gave earlier of summarizing a document that had factual errors in it could be an example of this difference, okay? So the idea is to remember that these neural language models, what does it mean when they're trained? So they're shown an awful lot of information, okay? So a neural network starts off with, it's a network with a set of things called weights or parameters, and they're randomly initialized, okay? So they're kind of random numbers. That's how we start the training process. And then we start showing the model lots of examples, okay? And the numbers that are in there, those random numbers, control how the model answers questions or prompts. And what we do when we're training a network is we update those numbers, those weights, those parameters, so that the answers the model gives match the training examples we give it, okay? And once the model's trained, those weights are fixed. Now you can think of those weights, those parameters, as like the long-term memory of the model. Okay, that's the long-term memory. When you're then deploying that model and a user puts in a prompt into the model, okay, gives it a new input, the long-term memory is stable, it's not changing. What is changing though is you give the model a new input, and that input causes a flow of activations through the long-term memory, okay? It's very different to the human brain, okay? But you can think of it that way of, you know, in the brain where activations spread through the network, okay? There's activations flowing through the network. And you can think of that as the short-term memory, all right? So the model has, when it's generating output, there's an interaction between its long-term fixed memory and its short-term memory, which has been activated based on the input the user has given it. And there's that trade-off, or there's a tension between those two. Now, if there's a difference in the training data and the prompt, then there's a difference between what the system's long-term memory is telling it and what the system's short-term memory is telling it, okay? There's a divergence, okay? So, and if the error happens to be in the training data, then if there's anything that makes the training data more likely or weight towards the training data, long-term memory, that will override the short-term memory and vice versa. The reason why so that's one reason why you can have differences between the training data and the prompt. And one other point I want to make here that I'll come back to later on is, that is why when we're training a model on like a huge corpus of text like the web, okay, it's really important to think about whether there's repetition in that data. So why does that matter? Well, think about a popular conspiracy theory. Okay, I'm not going to name a particular one. There's loads of them out there. Okay, that's on the web and is being, you know, there's an echo chamber and it's being repeated on the web lots and lots of times. Then if a model is trained on a big crawl of the web, and that, I'm not going to call it fact, that conspiracy theory was repeated multiple times in that data, that will make the biases, the long-term memory of the weights of the model really have confidence in that because it's seen it lots of times and it will override the short-term memory. And that's one reason why it can generate, content that might be related to popular conspiracy theories. And one of the ways we evaluate these models, there's a truthful benchmark data set, which is specifically designed. There's about 850 handcrafted questions that people put into these language models that are related to popular conspiracy theories to see how prone is a particular language model to conspiracy theories. Okay, I should move on to, but so that's another reason why hallucinations can happen. One, the training data and the prompt can have different information in them, and sometimes the training data isn't of good quality. All right. Another point, though, that is that can cause it, and there's others, is decoding strategies. Okay, so what our language model is doing, so we use that term autoregressive. What that means is that the language model is working from left to right through text, okay, or it's generating the next word in a sentence. And it does that by looking at the previous context and deciding or returning a probability distribution over the words it knows, where that probability distribution describes the likelihood of a given word being the next word to choose from. Everyone happy so far? So we have a probability distribution over our vocabulary. Technically, the word is conditioned on what's the previous context. Now, there's different ways that we can, given that probability distribution, there's different ways that we can sample the next word. The most obvious way is you take the word that has the highest probability in the distribution. Okay? Challenge with that is actually that has a bias towards more general, generic terms. Okay, because those words occur more frequently in training. All right. So if you only sample the most likely word, then your language model can generate generic text that's a bit vague, but it's also, let's call it, for want of a better word, this is definitely anthropomorphizing a model, like conservative in its worldview. Okay. Now, you could also change how you sample the next word given that probability distribution to add a bit more creativity into your model by allowing it to randomly choose from the top 100 words, okay? Or so there's a range of different strategies, okay? But the decoding strategies allow you, these decoding strategies, these are the strategies for selecting, given a probability distribution, selecting a word from that probability distribution for the next word. They allow us to, in a sense, trade off, conservatism, okay, and generosity with maybe creativity and specificity, okay, because you get more specific words if you go down the model, all right? So to give you an example of that, there was a research, the citations at the bottom there, exploring different, the effect of different decoding strategies on different models, all right? And what you'll have here on this side, so they gave a range of language models this prompt or the context. And if you use the decoding strategy, so you don't change how the model generates its probability distributions, but you change how it samples from those probability distributions. If you, don't worry about beam search, just imagine that this is a more conservative approach to decoding. You're just using the more likely probabilities. And this is you're allowing the model to be a bit more creative. Apologies for anyone who self-identifies as creative here, okay? Creative on this side, okay? It's got more room to choose from its distributions. And what you get on one side is kind of repetitive. It just gets into a loop where it just keeps repeating itself all the time, okay? On the other side, though, so that's where it's been too conservative and it just keeps repeating things. On the other side, where you give it pure sampling, you end up, what was the term they used, with incoherent gibberish, which is the framing for the red text, okay, where you've gone. So, and you'll have seen if you've tried some of the APIs for these language models, there'll be things like the temperature parameter or top K or top P for the sampling methods. And they allow you to trade off between these two extremes, gibberish and very conservative. And obviously we were talking earlier about questions like, plagiarism, etc. The more conservative you are in your decoding strategy, the more likely you are for your model to regenerate text that it has actually seen previously, and you might be infringing copyright. There's kind of different aspects along this where you might get, I want a bit of creativity. So for a chat, you might be midway between if I want a chat dialogue system, whereas if I want something that's more business-like, I might be more conservative. So this is one parameter that I think is worth paying attention to, and that, but it can cause hallucinations if we get too creative. Now, how am I doing time-wise, by the way? I should move on. So that's sort of the problem of hallucinations. So what I want to talk to you next is about the kind of an opportunity. Okay, if that's the challenge, what's the opportunity? Now, I'm an academic, I'm a researcher. Okay, so when I see opportunities, they might be very different to the way you see opportunities. So I see opportunities here as a whole load of research papers coming out in the next 15 years. Okay, so and that's dealing with all of the different approaches that we can explore and test to do what we call alignment. Okay, so alignment is that concept of how can we align the behavior of a language model so that it's useful and not harmful for the user of that language model. Okay, that's what we mean by alignment. And one of the things that will do is to reduce the hallucinations. Okay. So what I'm going to do in the next few slides is I'm going to basically give you a taxonomy of a perspective of a range of different approaches for alignment methods. Okay. And I'm going to, by the way, you can see I'm a computer scientist with the diagrams. My apologies for the color scheme. That's just somebody else would do a better job on that. But the first distinction I'm going to make is the difference between what we call hard prompt engineering and fine tuning. Okay. Now, what I want you to think about is hard prompt engineering as alignment methods. These are methods that the user, after the model is deployed, can utilize. Okay, because these are basically around how do I ask the question? You remember Anya spoke earlier about the different guidelines and advice that are being given for people to how to design the right question. So this is all about that, and it's called hard prompt engineering because there's a variant called soft prompt engineering over here. Okay, the difference being here we're actually editing the words that we put into the model in the prompt. Soft prompt engineering, we're actually learning embeddings that aren't necessarily human readable as part of the model that we append to a prompt. Okay, so the first difference is this side, the end user can do it. Okay, over here what we're talking about are changes to the model that we make prior to deployment, prior to the user getting it. Okay, so I'm going to quickly go down through a couple of high-level topics on this side and then on that side. All right, so if we look at the hard prompt engineering, this first branch, the first type and the most obvious type is called zero-shot prompt. All right, so you're just asking a straightforward question. And I'm sure you'll have seen, well, if you go on LinkedIn or Twitter or anything like that, you will have seen so many cheat sheets for how to ask a prompt, okay? And these guidelines, there's loads of them out there for how to, ask the prompt in a specific manner. The more context you give the system and the prompt, the better the response will be, okay? But then people went from asking, and these are kind of like, you can think of this as a chronological development, okay? Because people first just started asking these things questions and were impressed by the answers. And then they started thinking about how can they improve their questions to make the system more aligned with their goals. So you have a zero-shot prompt where you just ask a question straight away. A few-shot prompt, though, is where you start giving examples prior to asking the question of how you want the question answered. So I might have a prompt here where I say, okay, I want to turn this language model into a translation system. Okay, and I'm going to type in, the prompt I type in is, I'll say, hey, translate from English to French to give you some examples of what I want. Sea otter equals, my French is peppermint and plush giraffe, okay? You give it some examples with the French equivalent, right? And you kind of define your own operator here. You're just saying, okay, every time you see an equals to equals, the model is able to see, again, anthropomorphizing. It gets the sense that what the user wants me to do is, after it gives the two equals, is to put the French on here, okay? And that's the idea of, in the question that I ask, I give examples of the type of solution I want, okay? And that's called a few shot prompt. The idea here being that the few shots are the examples of the way you want the answer to come out to you, okay? And then people have extended this further by the concept of chain of thought prompting, which Anya mentioned earlier. So in chain of thought prompting it's like few shot, all right? So, but in the examples you give it, the examples contain reasoning steps, all right? So the idea is you are prompting the language model to step through its reasoning when it's answering a question and to give you those reasoning steps. And what's really strange here, and I'm not going to pretend that I know the answer here, is when we ask the models a straightforward question, it might get it wrong. And then you ask the same model to please step me through your reasoning to that answer, and it will get it right. Same model, okay? A little bizarre. So here, there's an example. We're asking it to reason about how many tennis balls somebody has, doing a bit of arithmetic, okay? And so this is the prompt, okay, with an example. So it's a few shot prompt. So example of a question and an answer, question, and the answer it gives is wrong, okay? Over here, we have a few shot prompt on the same domain, but in the answer that we give in the example part of the prompt, we illustrate, hey, we want this type of reasoning to be part of the answer that you generate for me, okay? So don't just give me the answer, give me an explanation of your reasoning, and then give me the answer. That's what the few shot example is. And you then ask it the same question, and it gets it correct, okay? So that's an example of chain of thought prompting. And there's a whole lot of research going on, lots of work going on, extending beyond this. There's tree of thought prompting and lots of others, lots of complex ways of framing the prompt so that we get the best out of the model for alignment, okay? To switch over quickly, though, to fine-tuning. So this is the stuff the user can do. This side here, though, is where we do something to the model, to the weights, to those parameters. It's long-term memory. We adjust that prior to deployment, okay? So the first thing you can do is you can get a large data set from the particular domain you want to deploy your model into, and you can retrain the model specifically on that domain, okay? And that might be full fine-tuning, all right? What I mean by full fine-tuning is you might update all of the weights in the network as you train it on these examples. And I have an example here from that source 12. It's a really nice blog by a guy called Sebastian Raschke. Has like a monthly magazine on AI. And he did this example here where he'd taken a language model and he had trained it on the IMDb data set and asked it a set of questions, okay? So what you're seeing here is if he only fine-tuned the last layer, the last two layers, for the model, okay? Over here, he's fine-tuning all of the layers of the model, okay? So as you move from left to right, it's the amount of the model you're retraining, okay? You'll see at the bottom that as you move from left to right, the compute cost increases, all right? What's interesting is that the training accuracy does increase for a while, but it doesn't continue to increase. It kind of plateaus out. So there's a point where you're spending more compute and your fine-tuning isn't giving better results, okay? So that made people think about what we call parameter efficient fine-tuning methods, different ways of choosing what portions of the data set or the model to fine-tune. And I'll come back to that in a couple of slides, okay? But in between, I'll talk about RLHF, which is another method for alignment, which is, and this is really the magic sauce behind ChatGPT, okay? So it's reinforcement learning with human feedback, all right? So the idea here is that you have your language model and it's generating outputs, okay? And remember, I told you earlier about the decoding strategies and the different methods for decoding strategies. That means that for any given prompt, we can get the model to generate lots of answers. It doesn't just have one answer, it can generate lots of them, okay? So you can think, one way of thinking about this particular approach here is you can say, well, there's a difference between being able to generate an answer versus being able to evaluate whether that answer is a good answer or not. So let's split those two things out, and we'll get the language model to be our generator, and we'll have another component that has learned to evaluate that, okay, to evaluate the responses. So I guess the main thing I want to say here with this, I won't go through, because definitely I'll be over time if I go through this, okay? The main thing I want you to know is there's an extra component now that kind of reevaluates the outputs from the model, right, the second part. And it uses reinforcement learning, but more importantly, it uses a huge amount of human annotation of generated answers to prompts. You know, we get lots of human work to, hey, here's a prompt, here's two answers, which do you prefer? Here's a prompt, here's two answers, which do you prefer? Imagine a huge amount of that happening, and using that data then to train that second component that's able to look at multiple generated answers and choose the best one, okay? And that was really part of the magic sauce that went on with ChatGPT. And just without wanting to plug it too much, but we've had, like, Adapt has been doing this type of work for a very long time, okay? In particular, when it comes to machine translation systems have been evaluated using that methodology for a long time. Here's two translations from two different systems, which is better, okay? And understanding how to ask the human annotators the best way to answer those questions is something we have a lot of expertise in. And I know also Anya is doing a lot of work on reproducibility in science, a really fundamental question. And and particularly in natural language generation, and that feeds into this area as well. So we're really well positioned to do work on this topic. And then finally, parameter efficient fine tuning. 3.5 minutes. So parameter efficient fine tuning. So these are lots of different ways of deciding what portion of my model I'm going to fine tune. Because if I don't have to train all of the model to get the alignment, then I can save on computational costs. Okay, and there's lots of different strategies for it. And Mohammed, I think, who's Anya's PhD student, has a poster later on who'll be able to talk you through that in more detail. Okay, but I think this is a really exciting area of research, partly because I think from this type of research democratizes the use of these systems, because using these types of solutions, somebody who doesn't necessarily have access to a huge computer can actually fine tune these models to their needs, okay? And not only do these methods democratize who can access it, but it also allows us to open up the number of voices that we hear within the community in terms of, because different people don't have access to supercomputer can now make contributions to this research field. So for the academic community, I think we'll have a more diverse set of voices coming through this research, but also for the users and for companies, this type of research means you don't need a massive supercomputer to do this work, okay? Now, I have 2 and a bit minutes. I know the next panel is more about AI ethics and data. So I want to switch focus a little bit for the last piece of my talk onto data and questions around data, okay? And this will, I think, chime in with the question we had earlier about the scaling laws of the models. To start that, I wanted to take, there's what we call the open language, large language model leaderboard. So this is a leaderboard for the performance of a set of language models that are open source, okay? And I took this snapshot as Olivia will attest to, because she got the slides late last night. So this is hot off the presses, okay? So I took this snapshot last night, and the leading language model at the moment is called Falcon, okay? The Falcon language model. So let's use that as a case study to think about data, okay? So the Falcon language model, it's just been released, okay? It has 40 billion parameters, and it was trained on 1 trillion tokens, okay? So when we talk about scale, where a token is sort of equivalent to a word, all right? In ChatGPT, a token is generally about 4 characters, okay? Because tokenization is actually a very interesting question. I have 1.5 minutes, stay focused, John. Okay, so how much data? Well, there's an answer, 1 trillion tokens, okay? So where does that data come from? Well, a lot of the data comes from the Common Crawl, Okay, so this is a not-for-profit organization that's been doing this for a long time, where they have been scraping the web for the last 12 years, just scraping the web. And you can go there and download the web if you want. Okay, that the Common Crawl corpus has petabytes of data. Okay, and I think a petabyte has 12 zeros. Okay, if we're talking about number of bytes. All right, that's a large number. So they get it from the Common Crawl, which is as much of the web as they can, like 12 years of crawling the web. Okay, so that's one thing. And people started training on things like the Common Crawl, but they realized actually that, hey, it's not just about the amount, but it's also about the quality of the data. Because as anybody who's gone on the web will know, particularly if you've been on Twitter, there's maybe a lot of not such high quality content out there. Okay, what's the acronym? NSFW? Yeah, not safe for work, folks. So there's another data set that's often used, which is the Pile data set. So this is smaller, it's 800 gigs. Okay, what's this composed of? And this claims diversity and variety. Okay, so this is things like Archive. So Archive is a preprint open source service where lots of academics put their papers up before they're published. Okay, so this is a whole lot of academic work. A lot of it being paid from the public purse is now being used. The US Patent Office is in there. What is it? GitHub's in there. Lots of the Stack Exchange, all of these sources where people have been, humans have been putting content up there for a long time. That's all being compiled. The reason what's distinctive about this and why they chose those sources is there's some type of quality assurance behind these domains. Humans have kind of been, let's say, a little more thoughtful in what they've put into their archive papers. PubMed is up there as well. Okay, so the Pile is there. And then there's another data set called Leon. I probably mispronounced that, but this is a set of images and captions. Okay, it's terabytes of data here. This is actually a subset of the Common Crawl data set that I talked about earlier. Right, now these three things I talked about, Common Crawl, Leon, and the Pile, you can go and download them. That's where this data comes from, because other people have aggregated all of this data online. Okay, I would say, well, I'll leave this to the panel who are more informed on this. Copyright. Let's just throw that out there for the topic that are going on. Who owns the data? Okay, and that's what we're going to. So going back to the need for quality. So this is the paper, 1st of June 2023. So this was published 6 days ago. Okay, this is why you don't want to be a hostage for fortune given your topic of your talk 3 weeks in advance on this domain. Okay, things change. So 6 days ago, this is the Falcon team. So it really is like that was published. The paper that they published when they launched was all about how the quality of the data that they used and how did they create the data set that they trained on. Okay, there's a discussion going on at the moment, which might be a bit strange, but because of the scale, the rate of growth of the scale of the data used to train these models is actually faster than the rate of growth of good content. I'm not talking about your normal tweets, okay, but good content. Because we're actually thinking that we will saturate, there's a discussion about whether we'll saturate performance on large language models in a few years. We'll just run out of data, okay? Hard to believe. Now, part of the story here is, with the Falcon team, is they're saying, actually, their results suggest that actually we can actually do okay without that there's enough data out there if we can automatically curate it, that we'll get good quality data sets for training, okay? So what they did was, most of this paper is around how do we take the Common Crawl and set up a set of automatic filtering methods in order to get good quality data to train our language model on, okay? And it's somewhere in there in the paper. They did reduce it by a large amount, but still end up with 1 trillion tokens, okay? So they do, while they're making the data set smaller for quality, it's still huge, okay? But I think it's interesting that that was the main point they wanted to make in launching that model. And then to finish, I just think this is an interesting thing. This is from April. I came across it. I thought it was a really interesting story. There was a freelance photographer, okay, found out there's a website, Have I Been Trained On, where you can check out whether your data is included in any of these, like Leon or the Common Crawl or that, and is it being used to train these large language models? this photographer went, saw that an awful lot of his images seemed to be indexed by these, and he requested that his data be removed from that lay-on data set. Okay, and there's been a back and forth, and I'm not taking a view on this because I don't have the legal, I can't afford it, or do I have, no, nor do I have the legal change, but depending on which jurisdiction you're in, you know, there's been copyright infringement or not, as I understand it. For example, in Germany, it's okay for somebody to like temporarily use data that's freely available, okay, even if it's copyrighted, and learn on it once they don't retain it, okay? In other places, it's different. I think Japan has changing things. So what I want to just finish off or tee up with here is there's a big discussion to be had about whose data is being used to train these models, okay? And the answers that and who owns the data and who has rights to use it. And I'm not sure that we're going to end up with the same answers in every jurisdiction. And it's a really interesting space to think about. So I think that's both a future direction and a challenge for work. Okay, so I'm finished there. Thanks very much.
Great talk. So this is just an example from use of language model in work context where we found in using the tool for some market intelligence type activities, you know, we got some very insightful responses in areas where we kind of feel that it's a bit more knowledge intensive, and very bogus responses in areas that kind of felt a bit more binary. What are your thoughts on what's going on there?
Yeah, so I think that comes back to the question of data, obviously, you know, and the variety of your data and the quality. So there's quality and variety. And I think that for the knowledge, if I'm interpreting knowledge intensive correctly, you know, that might be more like the data from the pile, you know, where the data in those domains, people have been more reflective in how they generated that content, you know, so there might be more coherent. Whereas in the other, and I don't know the other domains, I'll have to chat to you about it. The other domains, people might be more thrown out opinions, and there's just more diversity there, and the models are getting confused. Well, again, I'm anthropomorphizing, but there's just, it's a bit more like, you know, if we go back to those decoding strategies, if you think about that probability distribution, in some domains where there's more coherence in the discourse, the probability distributions generated at each step will be more spiky, you know, and there'll be more, the distribution of probability mass will be more local. So you'll be more confident in being able to choose. In domains where people are throwing out lots of things and lots of content, lots of words, less coherent, you're going to have higher entropy. You know, in other words, the probability math will be all over the place, and you're a bit more towards, no matter what your decoding strategy, you're a bit more towards the pure sampling side. You know, a bit less coherence and more creative in its content. I don't know if that aligns with what you were thinking about, but that would be my first thoughts on that, man. Okay. Yeah, not safe for work, yeah. Okay, cool. Thanks very much, everyone.
I positioned myself strategically there. So, okay, so we've heard about the amazing possibilities, how these LLMs work, and the opportunities and challenges in advancing AI, how we might use them in various industries. Because the big question, which seems to be dominating the news, is how do we think about privacy? How do we think about regulation? And what are the dangers of letting a technology as fast and as powerful as this go unchecked? Well, that's the discussion topic for this panel. I'm joined by Patricia Scanlon, Ireland's AI ambassador and CEO of Soapbox Labs. Senator Malcolm Byrne, Fianna Fáil spokesperson on further and higher education, research, innovation and science. I want to make sure I get the order right. Aoife Sexton, Chief Privacy Officer at Chuata, and Dr. David Lewis, who is an ADAPT Director looking at data protection, data ethics and so on. So let's start off with that first question, I guess, Patricia, as Ireland's AI ambassador. What are the dangers of just unchecked advancement in AI? What is Sam Altman and his peers? What are they so afraid of?
I'll be a little bit more cynical about their motivations. I think what's the risk is there's a risk now and there's a risk in the future, and they're two different things. And I think people are conflating them a lot. There's immediate risks of bias. One of the risks of bias and errors is that you can do so much at scale, instantaneously, hugely cost effectively compared to having humans do it. So you make an error in a model, propagated instantly, millions. I mean, the good example was in the Netherlands where 20,000 people were incorrectly flagged for fraud, welfare fraud, and had their payments cut and caused all manner of upheaval there. So unchecked and independently validated, regulated, allows for potential biases, discriminating one person than the other, particularly around their financial future, their education, their employment, their health and safety. So anything that affects a human needs to be just done carefully, right? If you just say, well, innovation for innovation's sake and let everybody off, you actually could affect someone's life trajectory, right? That's super important to do it. But you have to separate it with what the letter and the statement last week were about the existential threat to humanity. It's a different thing. So I think some people would rather you look out there to draw attention away from what's happening today. I'm of the mind, we don't know. We were all surprised, and I'd like to I'd ask anybody who was saying that they weren't surprised with how the progress of the transformer models and what we achieved. So if we're all surprised with how accelerated the pace was, and if we all acknowledge the power of AI and the potential power of AI, we need to regulate now and in the future. And you can't say, oh, innovate now, fix later, or let's make sure the robots don't come and get us. It's very hard to introduce legislation later. If you let it run rife now and you trust commercial entities to do the right thing, and then you say later, we're going to regulate. Well, when later? Next year, 5 years, when it's too late? How do you know when the right point is? So just put the guardrails on now. I mean, I think you can do it and still innovate. I think there's many industries that have innovated very effectively. FinTech, biotech, medtech. We see innovation everywhere that goes hand in hand with regulation. It's a powerful technology. Let's all admit we don't know if that existential threat's going to happen. I don't like the way the conversation's getting quite polarized at the moment.
I think it's really important to conflate not to conflate the Skynet, robots taking over nuclear weapons with, the very real day-to-day problems of bias you were talking about. You gave a really good example about education, how if you have educational software that is, that benefits or recognizes one particular, minority or a majority, if that's introduced into an education system, you could see just a widening of a poverty gap over the course of one generation.
Yeah, so we in Soapbox we do a lot around voice and in assessments and education, and what we saw was there was a case of speech recognition was brought to the classroom, was supposed to teach, instruct and assess literacy, and overall the class had a percentage increase. And it looked great until they drilled into the figures and they found out that one cohort were doing very well, usually more privileged, and the kids with socioeconomic backgrounds that were poor, and they had very strong dialects that weren't actually accounted for in the models, were actually not improving at all or disproving because they're probably being told they were wrong when they were right, that way. So you're bringing in these technologies a lot of time to address inequities in the classroom, and you're actually potentially, if you don't do it carefully, making them worse, right? Widening that gap. So what we've done and we've had to do is be very mindful of the biases in it and make sure that we're drilling down into all the accents, all the dialects, all the socioeconomic backgrounds and factors that can affect the AI's decision. So it's bias in a different way. We talk about bias and, being skewed about someone's employment, not hiring a woman, or if you were to leave it to the AI that wasn't trained properly, or, ethnicities, social background, addresses, all these things can affect someone getting a job, someone getting a loan. That affects your life, like your path, your trajectory. Like, so they're the immediate concerns that we're trying to legislate for now. We're trying to regulate, and you can do both. You can keep an eye on the future, but putting the guardrails in means you've more of a chance of addressing the future.
I think the ethical approach of Soapbox Labs is probably one of the reasons you were appointed the AI ambassador, is my guess. I'm wondering, you said you can, build it in from the beginning. Is that really what companies are doing? Are they building in ethics from the beginning? And by doing that, are you not letting the pack race ahead and beat you to the dominating that market?
Yeah, I think that's the knee-jerk reaction. The knee-jerk reaction is if we slow down and when we do the ethical approach, we won't win. And it's like, Jesus, really? Like, if you think about it, I'm trying to build a model that will work for everybody in the classroom, right? If I was building a software product and because I just didn't bother, it didn't work for half the people out there, I'd lose half the business. So what has happened with Soapbox is we've seen off nearly all our competitors over the years, because when it came to the question about data privacy and equity and lack of bias, they couldn't answer. So right now we're in the US and we got certified for mitigating bias in our AI models. That's now our marketing strategy.
Yeah.
We're doubling down on that. Our clients are using our logo on their websites because it means they are seen as an ethical approach to AI. So it didn't slow us down. In fact, it was just one of those things. Well, clearly nobody's going to use this in the classroom if it only works for it was just, to me, it was common sense. We didn't have regulations around equity when we started doing this. But it was just like, well, why would you bring a product to the market that doesn't work for everybody? I just kind of don't get that a little bit.
Eva, this is something that you have obviously a lot of experience in terms of, looking at data and privacy. And, the question is, this isn't the first time we've had, a lot of scare about data and so on. If we look at the past, are there things that we can learn from to make sure that we do better when it comes to this in the future?
Yeah, I think a couple of things. First of all, this new technology doesn't emerge into a vacuum. There are current laws that are in place. And what's going to be really interesting is the interplay between, new technologies like generative AI and current legislation. So, for example, great segue from John's presentation just on the training data itself. And there's a lot of opaqueness about the training data. But even if you look at the training data, you ask questions about data protection. So is my personal data in there? Where was it scraped from? Under the GDPR, if you scrape public data and you create your own database and you want to use it for a different purpose, then as a controller, you need to have a lawful basis, you need to have transparency, etc. And that's what happened in Italy with the Garante when they put a hold on what was going on there with ChatGPT. And they asked the right questions, but that was just one regulator out of 27. Then the European Data Protection Board said, whoa, we need to look at this. So they set up a task force. But it's going to be interesting even before the new AI Act comes into place, and we are aware that we do need new regulation. It's going to test the boundaries of copyright law, and we've seen that with the training data. And we're already seeing test cases happen in the US where Getty has taken an action around the use of its images. We see artists taking action about copyright and protection of their original works. And that was very interesting in the previous panel that Louis was talking about a new business model where there is compensation for original artists, but what if they don't like that? And what test cases are we going to have? And it's going to test copyright law because fair use is different in different jurisdictions. What about the Employment Equality Act and bias? If I don't get a job because I applied and the bias was in there where it didn't recognize that a female engineer would be as good to employ as a male engineer, could I take an action before the Employment Equality Act. So this is really going to test the boundaries of new laws, of the existing laws. And then we come to the AI Act. And what's interesting is we now know that that law won't come into play for at least 3 years. And in the last week or two, we've heard 2 European commissioners come out and say that's too late. So
It is too late. There's no question it's too late,
yeah.
right?
So Margaret Vestager said, okay, we have to have something in the interim. So we're going to have an EU-US code of conduct. And then Thierry Breton came out and said, we need a pact where it's voluntary code, and talking to Google Sundar to sign up to this. So you really wonder about how quickly regulation come out, and it will be a blunt instrument. And if you only have to look at the GDPR, it's 5 years in existence, and we're still trying to figure out how to interpret it. So the last case that the DPC came out with the 1.2 billion fine against Meta, what's interesting when you read the decision is there were 3 parts to the decision. The DPC actually said Meta should take 5 months and suspend the transfers. DPC didn't want to fine Meta. 4 regulators out of 27 said, no, this deserves a fine. DPC go back and come up with the fine, which they did, of 1.2 billion. But that shows you amongst the 27 member states how little consistency there is amongst the regulators in trying to interpret a very complicated law called the GDPR. So when you read the AI Act, you do go, wow, this is going to be hard to interpret as a lawyer, but also hard to implement and to enforce.
Yeah, David, like what do we see in this AI Act that will protect us? Because it is a bit scary that this is moving so quickly. We have that sort of black box a lot of the time with these large language models. People don't know how they work or what they've been fed. What will the AI Act do, and how can it possibly regulate something so fast and so widespread?
Yeah, I mean, I think it is a very good question because, exactly for this pacing problem, as it's known in sort of regulatory circles, that the fact that technology is moving way faster than we can react from a legal perspective. I think what the AI Act does, I think, which is really important, it does it in a very blunt way, but it's really important that it makes formally the link between, if you like, sort of product regulation. So it's built on an existing mechanism we have for health and safety in products, and it adds these 3 little words which are sort of and fundamental rights. So it covers health, safety, which we're used to doing in certain areas, and fundamental rights, which we're actually not used to doing. Okay? Right. From a product point of view. So this is the new thing that is emerging, and I think even from talking sort of legal scholars, that throws up a huge amount of sort of opportunity and a lot of complexity, because even from a legal point of view, there'd be very few lawyers who would be able to help you work across all of those fundamental rights. Lawyers specialize. So, you have copyright law, you have, perhaps academic freedom protections, hiring protections, and all of those are actually grounded. It's not that you have to reason that you're protecting the fundamental right, which is a reference to the European Charter of Fundamental Rights. It's a reference to the existing EU and national regulation that protects those. So that's hundreds of other acts that it refers to. So it opens up this huge amount of complexity just by adding these 3 little words. Okay, so in one sense, that's good because it formalizes that. It says, actually, we care about this. We need to start addressing this problem. But the Act doesn't tell you how to go about doing that. And I think what it does do is says, okay, here's the principle, but now I think, governments and companies and civil society need to figure out how do we actually respond to that? How do we build up the sort of networks of collaboration and communication to do that? Because, I mean, you're referring to Aoife, the discussions we have just between the data protection authorities in the different countries. That's a relatively small network of authorities compared to what the AI Act says, because already you have regulators in a bunch of areas like medical devices, automotive. There will be a bunch of new sort of government bodies that don't do product regulation very much currently, perhaps in education or hiring, who now will have to do that as well. So even, I did a quick tot up in Ireland, we're probably, looking at, nearly the double figures of government bodies who will have to do something in terms of, surveilling the market in a relatively small place like Ireland, and then they have to coordinate with the similar bodies in all the other national bodies. So there's a real complexity there, which I don't think has really been grappled with yet. I think it's understood that that's there, but I think there's a lot then that could be done that doesn't need legislation. It doesn't need primary legislation in terms of the AI Act, but it needs action by governments. So things like sandboxes, etc., pulling together the different actors so you can start communicating by that. So I think things like sort of codes of practice can start working towards that, because we know what the end goal is. We know what the principle is now. It's being laid out. We're going to have to get there. Like I say, 3 years is a long way off, and even then, enforcement in a meaningful way is going to be even further away. But we know the arena now, and we need to start sort of filling it with the right mechanisms.
Like, are we going to see fines for people who use a model that is biased? I mean, is that the sort of thing that we might see as a result of this AI?
Potentially. I mean, it has similar sort of levels of fine. Yeah.
Impact on an individual.
Yeah, I think you have to prove the impact.
Yeah.
And then the AI liability act almost puts the burden of proof back on. Puts it back on the company or the creator.
Yeah.
So it's getting complex.
Yeah, it does sound quite complex. I mean, I suppose at the same time, we're developing large language models that will make parsing legal text much easier, right? So you could employ these AI lawyers to fight with other AI lawyers, and we could just sit back and watch. How aware of what is coming, is on the horizon, Malcolm, is our government when it comes to AI, the very real threat to, I suppose, both privacy, bias, and also the potential for the widening of the gap between the have and the have-nots when it comes to technical dominance, companies like Google, Meta, or and so on?
I think the answer is probably not to a great deal, but I think that probably reflects society. And I think society is there's a mix of two elements. People see the opportunity, and what Mary was talking about the potential for better health outcomes. On the other hand, there are very genuine fears, and it's not just the fears about robots taking over our jobs. I mean, apart from even the legislation, our very society is based on concepts around trust, and AI has the potential to undermine huge levels of trust within society. And that can range from now where, we have learning models that can pick up my voice and within 3 seconds will be able to replicate and use my voice. Now you might think, okay, that can be, for somebody who wants to play a prank, that could be useful. But to the point of, if I suddenly realize, oh, I have to let an electrician into my house at home, I ring my next door neighbor, somebody's at the door. If they use my voice to be able to do that, that breaks down concepts of trust. And think about that in the context of child safety and so on. So there are huge, big challenges and fears that people have around society. Lewis' point about, think about how if we can digitally manipulate images and photography. Think about the current war between, Russia's invasion of Ukraine. If images are manipulated there, how governments will respond and react. I think for our democracies, and we've already seen the impact on elections and in referenda, we're going to be seeing, elections and referenda shaped by deep fakes, by image distortion over the next number of years. So our biggest challenge is going to be about trust. And I get the point. I think the AI Act, if it can be like GDPR, could be the most important piece of legislation this decade that the EU agrees and can set out those global standards. But there has to be a broader debate around our levels of digital and media literacy, what constitutes trust in society, how do we partner with companies? And I get the point earlier, Microsoft's point about everything being based on trust. I would even say from government's point of view, yeah, it's trust but verify. We've got to be able to send in independent auditors into companies to ensure that what they are doing is in the best interest of society at large.
You see that being a practical thing that's going to happen? And is that something that the government
it has to? Because frankly, I don't see fines as a big
it's very hard to get talent in the commercial industry, let alone find talent that's going to go in and investigate that talent.
No, well, I agree. So we enacted last year the Online Safety and Media Regulation Act. It has created what is probably the most powerful regulator in Ireland now, or very soon will be, Commission to Man, the Media Commission, which regulates not just traditional media such as News Talk and others, but the social media companies and so on for the first time. There is a real difficulty recruiting people, at a senior enough level. A lot of people paid attention to the 1.2 billion fine on Meta. Meta write that off as a business cost. It's really, we've got to be in a position to be able to change the culture of companies. And that does mean that in the same way, like with corporate enforcement and everything else, that government has to go in the interest of the consumer, in the interest of the public, go into companies and make sure that what they're doing is, if they're rolling out AI, that they do it for good.
Do we need to regulate all of AI, Patricia, or are there sections that are obviously much more dangerous and have much more serious impact for, like, should we be focusing where we point our regulatory lasers?
Well, yeah, and it is what's happening. So you have, because everybody thinks everything is going to be regulated. It's not. Everybody's going to be classed as low risk, medium risk, high risk, or forbidden completely. So again, it's for good reason, right? You're talking about the practicalities of the regulation and the implementation, the enforcement, and the teeth, to be able to do stuff with it. So a productivity tool that helps you write your email is not going to be regulated. There'll be some self-regulation or self-guidelines. It's the main regulation is around where it affects a human's life, health, safety, but they've also started bringing in the new wording of the text in the last couple of weeks has actually broadened to include disinformation, influencing elections, manipulation of humans, using emotion recognition, anything kind of deceptive, transparency, displaying whether it's a bot, transparency about the data that's in the model. So there's a lot more since late last year with the advent of the OpenAI, the ChatGPT. So they've included the idea of the large language models, but they've also included the foundation models. So the foundation models are the ones that can be fine-tuned that John was talking about earlier, the fine-tuning of the model, because how the EU AI Act was written before was all about the person that took the company or the person that took the product to market. And it was your responsibility if you were in the education, health, employment, any of these finance areas. It was whoever brought that product to market, but they've had to change that a little bit, because what happens now is you could have somebody sitting in, like a non-tech company, Kerrygold, and they're sitting there with all their stack of CVs they've got to go through, and they go, I've heard about this productivity tool called ChatGPT. I'm going to upload it all, get it to give me a summary, and maybe I'll even ask it to recommend who to screen, right? That person arguably doesn't know they're even dealing with AI.
Yeah.
So whose responsibility, if somebody was to say my career, my employment was affected by AI, who's responsible?
There's a lot of education required here, right? And the fact that some people don't even know what ChatGPT is.
Exactly. Yeah. And it's too easy to use. It's an interface and someone shows it to you and you start using it.
Yeah.
So, so previously the way it was written, it was the high risk use case was all about, because they were imagining narrow AI when there was a very focused, narrow task trained on expert data, usually by experts. And it was your responsibility to make sure it works correctly, not biased and all that. And now also this is kind of like not really what we expected to happen this year. I think we might have in the future, people would, and then when these things come along, we'll probably have to change the regulation. Now it's like, we're going to have to change the regulation. So there's going to be a huge amount of arguments in the next discussions, whatever it's proposed text. But you can imagine what's going to happen now, because it's pushed a huge amount back onto the companies like OpenAI and Google and Microsoft. Whose responsibility is it? If one of these systems were used to negatively affect someone's outcome, their health and safety, elections, who's responsible?
We've seen, but the point is, we've already seen that in many ways with social media. And we all know about the online harms that have resulted from social media. And I would argue, the genie was well out of the bottle before we started to take action. And I think
have not done it very effectively anyway.
We haven't.
Yeah, we missed
Yeah,
the boat on that one.
I think you're absolutely right. And there are a lot of parallels at the moment with the internet, the advent of social media, the cry for self-regulation. We're hearing that now again. Move fast, break things. Oh, we're putting it out there, but oh, just to warn you, it's risky. I mean, you know, with great power comes great responsibility, as Superman said. And one wonders.
Spider-Man.
Spider-Man.
Yes, I'm with you. That was Spider-Man.
Oops.
Can we put that into ChatGPT and see what
it was actually Uncle Ben, but anyway.
So you kind of wonder, you know, if we are to learn anything from the past, should we step back and ask, you know, are we placing too much emphasis on regulation? Because to your point about social media, this year, the Digital Market Act comes into play. This year, the Digital Services Act, they're actually trying to now regulate the dominance and the concentration of power of the gatekeepers. And we are seeing that parallel happen again, where there's a concentration of power into some very large organizations that are going to impose societal change on us, whether we want it or not. So you kind of have to think whether or not we need to be more creative in what we might need to do now to look at what is inevitably going to happen, which is displacement of jobs, inequity, and the lower skilled workers suffering the most, biases. And maybe we need more creative solutions, such as funds that will be set up to protect artists and those who are going to lose their jobs, and maybe a level of tax that will need to be placed on those where the concentration of power is, so as to redistribute what's going to happen inevitably here. And I wonder whether regulation is going to be what we need ultimately. And if we place too much reliance on it, I wonder whether or not we'll miss an opportunity now to have a wider discussion.
Yeah, I saw your brow furrow there, Malcolm. I guess it sounds a little bit like subsidies for farmers in a way to not use their land for farming. Would you agree with the idea of paying artists who might be out of work, or at least in some way protecting parts of our society that might be displaced?
I think we've got to look at how we can continue to support creativity. I mean, there's 2 points I'll make. One, which relates to the education side. I mean, it's been very interesting, the response of the education system generally to ChatGPT, and it ranges from everything from ban it, right through to let's play around with it and see what happens, even though the dangers aren't fully explored. So I think the response of our education system has to be, this technology is going to happen. We've got to look at ways where we can ensure that students understand where we can use it and where we can't use it. Because it's happening, it's out there. I go regularly to talk to groups of second level students, and one of the questions I would ask is, I get the teachers to turn away and I ask, how many of you have used ChatGPT to help with your homework? And at least a third always admit to using it. So it's there and it's happening. I think it comes back, and I'll share an experience which we had with the Online Safety and Media Regulation Act. I think it comes back to the question about responsibility. We've got to start to get people to take responsibility, and this in the same way as we did with environmental law and with health and safety law, we make individual directors responsible. Because you can find, I become more and more convinced, you can find some of these companies huge sums of money. They write it off as business costs.
Yeah, maybe just add a zero.
Yeah, but you could continue to add zeros, but you've got to have a situation whereby within a company, if somebody goes to the director of engineering and says, listen, we can roll out this new platform, or we can roll out this new app. Yes, it has the potential to make us billions, but there may be these potential knock-on harms. And if you make the decision to roll out that, you have to take responsibility.
Yeah, and look, individuals would be very nervous about that, because I do feel like companies are able to sort of shift around their assets and their people to avoid proper inspection. David, this seems to me to be a place ripe for Adapt to Lead, because there's a center of expertise here with international partnerships, academic and industry, to really help this cohort in this room, but also the country understand the implications, how we could lead in Ireland, and how we position ourselves when it comes to protecting rights of humans in Ireland and abroad.
Yeah, I mean, absolutely. And I think I'd add to that, you know, academia, industry, government are really important. But I think civil society is going to be really crucial here. I think the answer with many of these things, like how are we going to, test or assess or do a risk assessment on a particular technology? What is,
And is that doing stuff in this
Yeah,
area?
absolutely. So we run a program called Discuss AI, which is part of our public outreach, ranging from things like sort of citizens juries to various forms of sort of citizen thinkings held throughout the country, where we can go with very specific topics, but get used to that discussion with with people who come along with their concerns. I think there's a lot we can do to improve that, systemize it a little bit more. Certainly our experience through running things like citizens assemblies and citizens juries, you have to put money into it. You can't just have a session and hope people turn up. You have to try and get some prolonged engagement. There needs to be engagement with companies and government, and people who get involved in that discussion want to see, well, what happened? I turned up to that event, we gave loads of good input. Did something come out of that? We had a lot of that experience though through looking at the use of health data, for example,
right?
Patient groups.
Yeah, people are happy to share their data. They're happy to get involved. They want to see something done with it if you ask for it.
Yeah. Because again, otherwise it's just seen as a sort of yet another example of our stuff in and their stuff out. Like we're contributing, but what are we getting out of it? So I think the example of perhaps giving people a bit of compensation. I think the language actually a little bit is the analogy is just transition as we see it in environmental. We're saying, well, some people are going to be worse off because we're requiring them to produce less carbon, and we need to manage that change. And I think we can see that for example with people in the creative industries, it's not the fact that they're not going to be able to do what they're good at, but it's changing so quickly, and we need to sort of help with that transition somehow and understand how that's going to work. And I think that's a real challenge. We don't really have any sort of very good models for doing that currently. So those are the sort of things we're looking at in Adapt.
Jonathan, I was just going to make a point also about
just raise your hand if you have a question. We'll come to you. Aoife.
I work in privacy tech, so we're a nascent new industry sector that emerged as trying to find solutions for companies that want to innovate with data, but how can they do so in a responsible and ethical way? So we look at anonymization, pseudonymization, synthetic data, federated learning. And some of these can be used in AI, but there's a parallel also to how can we use technology to solve problems that technology has created. And some of those could be research into areas like trying to using AI to identify deepfakes or provenance of AI and things like watermarking. But we have to be careful where the funding of that comes from, because it's not necessarily in the interests of those companies that are producing and making millions out of the AI that's being developed and deployed. So back to the toolbox, what's in our toolbox to help here? Not just regulation, but also technology to help solve some of these problems that technology has created.
Yeah, very good point. Aoife, yes, question over here. Let's hear.
Hi, so my question is just on basically open source versus the incumbents, because you guys talked a lot about regulation. And it's a lot easier to regulate these 5 big AI companies, but then there's also open source. So there's a lot of AI tech now can be fit onto small little hard drives on a laptop, and it can be customized, and it's all open source. But then people can do whatever the hell they want. They can train data and not compensate people or do anything like that. So what do you guys think about the trade-off between having an open source ecosystem or having kind of a couple of tech giants but it's well regulated?
Before you answer that, Patricia, I'll give you an anecdote that kind of highlights the problem. I was having a conversation with an Irish founder, not far from this part of the world, and I was asking him about the data that he got to train this model, and he said he ordered it off the internet, and it came in a jiffy bag with a USB stick, and that was all. And the data was on it, but that was all the information he had. And, you know, that's a small company trying to get something to work. I mean, the regulation's fine when it comes to Meta and so on, but there's lots and lots of companies out there who are getting data just to make whatever it is they're working. And that sometimes scales into being a unicorn. So it's a good question.
It's a really good question. So open source, whether it's the software or whether it's the data, right? So you can still take an open source system and test it and ensure it and fine tune it and add data. You know, it's still your responsibility to make sure it works. Let's say, like what we do, we brought it into the classroom, all kids use, does it work for all the accents and dialects? Is it biased in some ways, to, you know, in any way, right? So you have to look at all the edge cases. It's open source or from, let's say you're licensing OpenAI's GPT-4. Doesn't matter, it's still your responsibility at the moment. And it should be, right? Because you can fine tune it. If you take, you could take Lambda, you could take the Llama, you could take the GPT, you can still do work on it yourself. So it doesn't matter whether it's open source or private. You can still make sure that the product you bring is ethical. You know, that doesn't remove, or even the person with the data in the Jiffy bag, like, you know, they could still parse that data and use the right amount and in the right way. And they could still test their system. It doesn't stop them doing that if they choose to.
Right, yeah.
Right, you know, and eventually they'll be compelled to. So to me, it seems that why would you start to build any AI system that isn't responsible, let's say, right? Because in a year or two time, you're literally going to have to scrap it and start again because you just couldn't be bothered. But you were rushing it to market.
But is it practical to ask someone to be completely transparent with all the data they've used? I mean, if
no, that's it's quite simple how you do. We went through it's called artifacts. Like you're gonna have to document, right? It's literally just around good processes. If anybody here today is going to start from the get go, what data did you use? What were your use case? What were your edge cases? Who are the people going to be using it? Did you think about how you're going to mitigate bias? It's not that hard. People, because people just haven't looked at, like, look, you know, just document as you go. Make sure you've had discussions about how it could go wrong, and then you address how you can correct it. Again, you know, it's not beyond the reach of most people.
David, we have maybe time for what? Do we have time for? We have time for one more question. But David, do you want to?
I think that's a really interesting question. There is an emerging sort of movement about responsible AI licenses at the moment, which really is saying, well, if you're using our model with open source license, don't use it for these bad things, which is sort of it's more sort of, avoiding risk for yourself and making that available rather than anything that's very enforceable, because that would only be enforceable through sort of copyright law. So I think, there's a long way to go there. I think, we've got to, that same enthusiasm about doing things in the private sector that we might see also in the academic sector. So, well, let's make it open source to enable it to move forward more quickly. Doesn't avoid the fact that you still need to put those checks in.
Yeah.
So I think it is an important part of it, but it's sort of orthogonal to these issues of responsibility.
Can I just add one brief sentence, because I agree with the points, but we've also got to remember we're chatting in the context of societies that are democracies where the rule of law and human rights still hold some value. We've also got to consider about how AI will be deployed in other societies. And to your point, I mean, I would have whatever flaws you might think about the government here or the European Union, I would have a lot more concerns about how, for instance, the Chinese Communist Party is deploying AI.
Right. Paul.
So it's actually just going to ask that question. If we, as somebody who's really invested in this, do we run the risk of legislating against the good actors, people who are really interested in do something, and creating a free-for-all and bad actors states and places like that for malicious people to go train models, host models, and bring all this.
I think that's always two things people say. Regulation stifles innovation, which I really don't agree with, because there's a lot of innovation in highly regulated spaces. And secondly, if we regulate, we'll lose to China and Russia. And you're kind of going, well, we're going to lose what exactly, right? So if we don't regulate, we're not careful, we could actually risk destabilizing our own governments and economies, right? Is that a good thing? Or I don't think it's a great look to be taking on anybody when you can't keep democracy in check, So I think you have to be kind of careful, because they're very good arguments that people keep throwing out there because they don't want to be regulated. And it's often the commercial entities and the lobbying that's happening to do that,
Right, I think that's time. Fascinating discussion, and thank you so much to our panel, Aoife Sexton, David Lewis, Malcolm Byrne, and Patricia Scanlon. Thanks very much.
And it's so interesting to see the range of application areas and the use and applicability of artificial intelligence across all the modalities. So ChatGPT, the fastest growing platform ever, 100 million monthly users by the beginning of the year. It's still an extraordinary statistic. You know, there's still this huge public distrust, maybe, or uncertainty about it. There's a lot of ambivalence. There's, you know, extreme positions in the discourse, a lot of concern in political circles in Ireland and in Europe and further afield. But I think today we saw from basic language models that we've been researching for over 20 years for NLP tasks, then to machine translation, and now to more general purpose artificial intelligence for language generation, for search and dialogue and more. Anya told us about tool augmented LLMs and asked, really, are they still large language models or are they something else? And I think they probably are. Self-training AI for general use. It's no longer this narrow AI. And Trish earlier was also surprised at that, as many of us were. So this is the big story, tool augmentation, LLMs, as something that we should be more attentive to. By any measure, this is a disruptive technology and something that we all need to be alive to. Microsoft has invested very heavily in OpenAI, as we know. I think 10 billion was the number I had heard, which is just extraordinary. You could run our health service for half a year on that. It's so when you say that, it isn't such a big number, but it is a big number. So the technology will obviously power the next generation of Microsoft's products, and we've seen some clues to that. But we're seeing generative AI across a range of modalities in speech and image and video generation for software developers in health and healthcare, and interesting new models emerging. We heard from Louis from Shutterstock earlier, just about this kind of collaboration between humans and generative AI to generate new images and the emerging business models around them. So a lot of really interesting stuff happening. We heard about the risks as well as the opportunities and the need at this time, I think, for level heads and systematic research in a range of areas. I mean, I was kind of counting earlier, there's at least 10 distinct research topics that deserve attention at this time. So key question is, how do we strike this balance between, on the one hand, fostering innovation in AI and ensuring robust data ethics and regulation on the other, and that they're not mutually exclusive, they're not opposite sides of the same coin. And there's a real opportunity, I think, for Europe, for us here in Europe, to actually find out where that balance gets struck. John spoke about methods for adaptation and alignment of models to address issues of accuracy and veracity. So there's lots of opportunities for us to collaborate together. So the key question, I guess, is of today, for me at least, is how can industry and academia collaborate to overcome some of these challenges and to harness the opportunities that these disruptive technologies afford? So we can bring new innovations from idea through to reality through research partnerships. And we've done that with many of our industry partners. Within ADAPT, you've got access to world-class experts across disciplines, and this is really important. It's not just computer scientists, and arguably it should never be just computer scientists, because social science, arts and humanities research is all really important here. Research in ethics and philosophy, as well as experts from the medical domain, psychology, neuroscience, and others. It's really, this is almost like a whole of university problem to solve, in a way, and a whole of society problem. You can build your future workforce by collaborating with ADAPT, by having embedded researchers through targeted projects and so on, working with your staff, embedded with your teams. It's good for the research because we access use cases and scenarios, we access real world data, but also subject matter experts. So there's this sort of diffusion and transfer of knowledge through those sorts of engagements. And we provide opportunities for internships and for PhD studentships. Dave, earlier on his slide, I think had some of those in the impact slide on the right-hand side. Specific projects around model development or tuning or evaluation, HCI collaborations, you name it. We collaborate in a lot of different areas, and we do these through collaborative research projects, one-offs over the course of a year perhaps, or through longer term research joint labs. So we have a number of these with certain key partners, and they might run for 2 or 3 years. And within that, there's a portfolio of different projects. Some of them might be longer term, some of them might be more ambitious, more moonshot, some might be tactical, which are, you know, nearer term and resulting in a more tangible prototype or proof of concept system to evaluate. Through ADAPT as well, you can engage with workshops and consortia who are influencing and shaping policy and future regulation. So really to the last panel, you know, Dave in particular has been on a number of international standards groups, and we engage with government here and in Europe to influence policy and to share our expertise. And we can, you know, we can connect in industry with that discourse as well. And then finally, access to Irish and European funding through our university partnerships. We have one particular funding model for our targeted projects with industry, where we can offset pretty much half the cost of the collaboration using our existing Irish government grant through Science Foundation Ireland. So it's very generous, but also at a European level, we can be a conduit to Horizon Europe funding in particular. And my colleague John Judge is here, who is pretty much an expert at finding those opportunities for European funding, and I'm sure he'd be happy to talk to you about it. So you got to see 4 ADAPT researchers today on the stage. There's several other ADAPT researchers here. Please, ADAPT researchers who are here, make yourself known and have chats during the networking session afterwards. We've also got 10 posters, so therefore 10 other ADAPT researchers in the room today. Their posters are on display. They are passionate researchers. They're experts in the areas that they are going to talk about. So please do visit them if you haven't already. So we're ready to engage on your innovation journey. Sorry, I should say, of the topics earlier, the reason we can do this and adapt is because we're a large research center. So even by international standards, you know, well over 80 principal investigators and funded investigators across 8 universities. And of the 4 professors who are here today from ADAPT on the panels and talking, they come from 4 different host institutes within ADAPT. And it's this virtual research centre across 8 universities in Ireland. It really gives us this scale. So even by international standards, over 350 researchers in human-centric AI is it's up there with, you know, Carnegie Mellon or MIT or Stanford and what they can offer. So we really do punch above our weight. So we in ADAPT, we're ready to engage on your innovation journey, so we can provide expertise in AI and advanced technologies. We can help, you know, inform and co-design your research and development strategy. We have expertise on governance and ethics. We can help with capacity and capability development in your organizations. So reach out and let's schedule a call so we can engage. You have the business development team here. So Conor McNally is here, Kieran Flynn is here, Edmund O'Connor is right over here, and myself. We're happy to talk to you. If you want to get in touch, either talk to us today or get in touch via collaboration@adaptcentre.ie, and we would be happy to set up a discovery workshop. This is a completely pro bono. This is good for the research. So if you've got some interesting ideas, if you've got some needs, do please come and talk to us. Just the second last thing I'll say today is, and I'd forgotten to say it earlier, thank you so much to Tangent for hosting. So Tangent is Trinity's ideas space, and they're the key entity that supports student entrepreneurship. They work across all schools and faculties in the university, but also their facilities, which includes this big space, lots of IT and AV equipment, collaboration rooms over there, and meeting rooms over that side. So if you want to get in touch, track down Anya or Ken in Tangent, and I'm sure they'll be happy to help if you've any needs there. And finally, I want to say thank you to everybody who made the effort preparing for today and for attending, for taking part. Malcolm, and thanks for taking part in the panel discussions, and to all the panelists, of course, and to Olivia and Alex and the wider team for putting so much effort into this event today. And for those, you can let people know if they weren't able to make it, and if they registered for the catch-up version, we'll be sharing a video of this event as well afterwards. So thank you very much. Stay for the networking and stay for the posters, and that's it. Thank you.